क्योंकि अब हम फिर नहीं रहेंगे मंडे को, मेरा कोई काम ही तो जितने भी मुझे मिले एक नौकरी वाले वो ढूंढ के हम ले आए। अब हमको नहीं मिल रहा तो हम क्या करें। एक और काम है ना कि हर चीज में पेन ड्राइव में लेते चलो।
सबसे बेस्ट वही होता है, अपनी अपनी जानकारी अपनी अपना रख ले, बस अपना
क्योंकि ये लोग ना बहुत से ऐसे काम करते हैं नहीं कैजुअल। नहीं ये था कि हम लोगों को उसका समझ में नहीं आता किस फॉर्मेट में दे रहे कैसे ले रहे क्या कर रहे कि ये बस इसी कंप्यूटर में होगा IQSC वाले में ही होगा या इसी फॉर्मेट में होगा।
ये परसों भेज रहा
Hello. Hello.
Good evening, good morning, everyone. It gives me immense pleasure to extend to you all a very warm welcome on behalf of the Government Model Science College, Riva, who has clubbed all of us for the national webinar on recent trends in physical science. We are thrilled to witness such enthusiastic participants and highly learned audience gathered by online platform Google Meet to deepen their understanding of the significant topic. Today's webinar on recent trends in physical science aims to bring to light various aspects associated with this topic. This webinar is designed to engage us all in thought-provoking discussions and stimulated fresh perspectives on our fascinating focus topic. I would like to welcome respected Professor Hardik Saxena, Principal of our college. We have with us two eminent speakers, respected Professor S.K. Tripathi, Professor of Physics, Mahatma Gandhi Central University, Motihari, Bihar, and respected Dr. Vijay Misra, Sir, Assistant Professor, Atal Bihari Vajpayee, Hindi Vishwavidyalaya, Bhopal, and all participants of all over the country and abroad who are connected with us via online mode. On behalf of the college, I welcome to all of you. Now, I would like to request Dr. Yash Kumar Singh, sir, for a brief introduction and motive of this webinar. Dr. Yash Kumar Singh.
Thank you, Sandeep ji. Thank you, Sandeep ji. सबसे पहले माँ बीड़ा वादनी के चरणों में सत सत मेरा नमन और हमारे आज के नेशनल वेबिनार के मुख्य अतिथि हमारे ऑनरेबल हमारी प्राचार्य हमारी संरक्षक प्रोफेसर आतिश सक्सेना मैडम, आपका स्वागत है। आज अपना बहुमूल्य समय आपने दिया और साथ ही हमारे जो मुख्य वक्ता के तौर पे हैं महात्मा गांधी सेंट्रल विश्वविद्यालय मोतीहारी बिहार से एस.के. त्रिपाठी जी, आपका भी ऑनलाइन हो चुके हैं। आपका भी बहुत स्वागत वंदन अभिनंदन है। और दूसरे जो हमारे मुख्य वक्ता के तौर पे हिंदी विश्वविद्यालय अटल बिहारी विश्वविद्यालय भोपाल से डॉक्टर विजय मिश्रा सर हैं, आपका भी इस वेबिनार में जुड़ने के लिए आपको मुख्य वक्ता के रूप में होने के लिए आपको बहुत बहुत आभार, स्वागत, वंदन। और साथ ही जितने भी पार्टिसिपेंट हैं हमारे स्टाफ मेंबर हैं उन सबको भी स्वागत अभिनंदन। ये जो टॉपिक रिसेंट ट्रेंड्स इन फिजिकल साइंस जो रखा गया है ये बहुत सोच समझ के करके इसलिए रखा है कि वन साइड वेबिनार ना हो। फिजिकल साइंस के अंतर्गत जितने भी गार्ड चैप्टर हैं सब लोग सहभागिता से इसमें पार्टिसिपेट कर सकें और अच्छे तरीके से जो भी हमारे शोधार्थी हैं उनका भी जो ज्ञान है वो अपने ज्ञान विज्ञान रूपी रिसर्च शोध पत्र के रूप में इस वेबिनार में अपना पार्टिसिपेंट दिए हैं। ये हमारे महाविद्यालय और हमारे आज के कार्यक्रम के लिए बहुत ही सुखदायी है और निश्चित रूप से एक स्मारिका का अभी विमोचन भी हमारे आदरणीय प्राचार्य महोदय के माध्यम से और हमारे इंडियन जो स्पीकर हैं ऑनलाइन अभी किया जाएगा। और मैं ज़्यादा समय न लेते हुए मैं अपनी वाणी को यहाँ पे विराम देता हूँ और आगे की रूपरेखा के लिए मैं संदीप जी के पास जाता हूँ। धन्यवाद।
Thank you so much, sir. Before we start the lecture sessions, it's time to release of the souvenir of this webinar. For this event, I would like to request Professor Aarti Saxena ma'am, Dr. Yash Kumar Singh sir, Dr. Deven Sharma sir, Dr. Lakshmi Tripathi, Dr. Ashish Gupta kindly release the souvenir. Video on this. Thank you so much to all of you. Now it's time to hear a few words from our patron and principal. With respect, I humbly request our principal, Professor Aarti Saxena ma'am, to please say a few words as a blessing to us. Ma'am, it's over to you.
Thank you, Sandeep ji. Respected Professor S.K. Tripathi ji from Motihari, Bihar, Dr. V.K. Mishra ji from Bhopal, Dr. R.N. Tiwari ji, IQAC in charge, entire staff of Government Model Science College, and dear participants and students. From the core of my heart, I welcome you in the national webinar on recent trends in physical science, organized by the Department of Physics of Model Science College, Rewa, sponsored by Department of Higher Education, Bhopal. We are highly honored to have such a huge participation and very long list of enthusiastic researchers eager to present their papers in this webinar. According to Ryan Holiday, writing a research paper is a lot like a military operation. It takes discipline, foresight, research, strategy, and if done right, ends to a total victory. And the battles that count aren't the ones for gold medals. I am very sure that today's event will be an interesting as well as enlightening experience for all of us, in which new ideas and new facts will be shared. We all know that we need people around us who have same goals and moving in the same direction we want to go to succeed. The webinars are a very good medium for that. Only reading research papers are not sufficient. Instead, webinar and seminars are great help in fixing new ideas in the mind. Actually, research is to see what everybody else has seen and to think what nobody has thought. Once again, I will like to welcome our distinguished guest speakers, Professor Santosh Kumar Tripathi, Professor of Physics, Mahatma Gandhi Central University, Motihari, Bihar, and Dr. Vijay Kumar Mishra, HOD Physics, Atal Bihari Vajpayee, Hindi University, Bhopal, MP, and thank them for sparing their valuable time and accepting our invitation. I would like to thank Dr. Yash Kumar Singh, HOD Department of Physics, convener of the webinar. Dr. Devendra Sharma, organizing secretary. Dr. Lakshmi Tripathi, Dr. Archana Shukla, Dr. Ashish Gupta, Dr. Umakant Sharma, and Mr. Sandeep Kumar Tiwari, along with Dr. Ashish Sen of Computer Science Department, for organizing this event very efficiently and making me proud. I thank all the persons working behind the curtains for this event. And last but not the least, all the participants who will make this event a grand success by their presence. I wish all the success to this great event. Thanks. Jai Hind, Jai Bharat.
Thank you so much, ma'am. Now our first speaker, Professor S.K. Tripathi, sir, who is the specialist of energy storage devices, water treatment, water management. He has received TST TAAD Fellowship, which is a project-based personal exchange program under Indo-German Joint Research Collaboration, funded jointly by Government of India and Government of Germany. ISCA Young Scientist Award in the Material Science section of the 92nd Conference of the Indian Science Congress Association, held at Nirma University of Science and Technology, Ahmedabad, Gujarat. Professor Suresh Chandra Medal for the best paper presented, Young Scientist in 6th National Conference on Solid State Ionics, held at Jadavpur University, Kolkata. Besides this, Professor Tripathi has published several research papers in international and national research journals and conferences. He had been member and lifetime member at several prestigious society and committee related to the physical science. Without any delay, I am honored to invite Professor S.K. Tripathi, sir, our first speaker of the day, for his lecture. Professor Tripathi, sir, it's over to you.
Yeah. Thank you so much. Thank you so much, Dr. Yash Kumar Singh ji, convener and head of the Department of Physics at Government Model Science College. I am not sure whether I am audible to you and I am visible to you people or not. I am not sure about it. I don't know whether some.
You are audible, sir. You are audible.
So, I am audible and I am visible as well.
Not visual, sir. Audible only.
Audible but not visible. Okay, anyway, I'm still trying, but let's, without wasting much time, let's proceed ahead. So I would like to, first and foremost, I would like to thank entire organizing committee of National Webinar on Recent Trends in Physical Sciences, Government Department of Physics, Government Model Science College, RIVA. Hello. Is there any problem? Am I audible?
No, sir. Go ahead.
Oh, yeah. Thank you. So, I would like to thank Professor Aarti Saxena, Madam, Patron and Principal of Government Model Science College, RIVA. I would like to thank convener of this national webinar on recent trends in physical sciences, Dr. Yash Kumar Singh, sir. I would like to thank Mr. Sandeep Kumar Tiwari ji. I would like to thank Dr. Vijay Misra ji, who is special, who is a distinguished guest for today's lecture as well in this webinar on recent trends in physical sciences. And in fact, I would like to thank entire organizing committee and entire Department of Physics for organizing such a beautiful webinar on recent trends in physical sciences. So today, let me share my slide and I'd like to know for my knowledge that how much time I'm going to get for presenting this presentation.
50 minutes, sir.
Okay.
Approximately 1 hour.
Yeah. I'll try my level best.
Okay, sir.
So my screen is visible to everybody.
Your screen is not visible till now.
Okay, just a minute. Is it visible now?
No, sir.
My screen is not visible.
No.
Oh, just a minute.
Due to some technical problems, Professor Tripathi is not visible still. All the participants, please be patient. We are trying to keep him on the screen.
ये कितने हैं और ये कितने
Yeah, is it visible now? Hello.
Yes, sir. Yes, you are
Am I
visible and
audible?
your presentation is also visible.
Okay, thank you. Everybody. Well, so the topic which I have chosen today is harnessing biowaste. Yeah, I don't know. Kindly mute your audio. Yeah, kindly mute your audio. I would like to request all the participants kindly mute your audio, please. Well, so the topic which I have chosen today is harnessing biowaste, a comprehensive approach to energy storage and conversion application. So you'll be able to see nowadays, because of the pollution level in the environment, so from environmental pollution point of view, climate change point of view, sustainable development, United Nations Sustainable Development Goals under the aegis of Envision 2030, 17 goals has been set up by United Nations. So in that point of view as well, you'll be able to see these are the 17 goals in which again we have a mandate to mitigate these problems related to climate change, related to renewable energy, sustainability in the technology advancement, whatever you are planning to design any new equipment, any your devices as well. So the mandate which we have is that we should use or we should utilize, and of course due to depletion of these fossil fuels, day by day it is depleting to a very scarce situation is about to come from fossil fuel point of view. So keeping all these points in view, there is some amalgam of these all these topic. Of course, if you're talking about circular economy point of view, so I have chosen this harnessing bio waste. So again, management point of view as well, because it is going to be a very problematic issue, not only from Indian context point of view, from global context, in global context as well. If you're talking about this waste management, it is a very big and challenging issue nowadays. So municipal solid waste, if you're talking about, so let me yeah, so let me start from the waste point of view. What exactly waste is? So a definition is garbage that is discarded after primary use. Means if you're going to use some material, if you're going to use something for your from some product, domestic product or any sorts of product, if you're going to use it, so primarily after using it, if you're going to discard it and it is not of any use to you, it comes under the category of a waste material. So again, greenhouse gases and that different toxic skies are there just because of chlorofluorocarbon and your, of course, climate change. That temperature is going up day by day. So in order to resolve all these sorts of things, of course, whenever you are planning any technological advancement, all that you need to do is that you have to go for the holistic approach. You have to go for the development. You have to design any technology in such a manner that environmental issue or environmental pollution has to be taken care of. So when you are talking about the waste is a garbage which is discarded after primary use. And these are some data of the most polluted city, and this data is I have taken from this data is in 2020. It was published in 2020 by News 18 Creative, and average PM 2.5 microgram per cubic meter. So you'll be able to see that China, these are the cities in China, India, Ghaziabad, Bulandshahr, and these sorts of cities. Some Vistrak, Bhiwadi, Noida. You'll be able to see in India, many different cities are there, including Faridabad, Delhi, Jind, Hisar, and again some Kashgar in China. Most of the polluted cities you'll be able to see it is present in India only. So, and these are the indicator that in which range it becomes hazardous, very unhealthy, and then moderate and good. From the level of average PM 2.5, in which range it should be not more than 100 microgram per cubic meter. From moderate, it is under the moderate level. You'll be able to see that 50 is a good enough. 50 indicator is a good enough, and something like that. So now coming to the material. So whenever you are designing any material, so first and foremost point is that you should understand what exactly material is, what is the life cycle of the material, what is the processing mechanism of the material. So whenever you are designing any material for any specific application, all that you need to do is that you have to choose certain suitable precursor or building block of that material. So what exactly you are going to do? You are going to take some building block, or you are going to take some precursors, which is going to act as a material precursor, of course, which is going to act as a input for any desirable application. You are going to do some processing over there, of course, using some equipment. It depends whether which type of metal you are designing, and depending on the requirement of the material, desired product you are looking for, you have to go for certain steps or certain processing steps, or in a technical term you can call it as a favorable processing condition has to be applied on precursor material, so that you are going to get a desired material over there. Of course, it may include some you can put your material in your furnace and burn it under certain ambience condition, which has to be tailored and in different environment, sometimes in nitrogen environment, sometimes in argon environment, and lot many different controlling parameters and environment exist over there. and a lot many plethora of literature articles is available in the literature. So the entire cycle is something like a desired material. Now that desired material, you are going to use it primarily. You are going to use that material, means the desired material, by a human being. You are going to use it after using these material, desired material for desired application by human being. If you are going to discard it, it becomes waste material. Now here, I'll show you in due course of time. So that discarded material, now you have to here technology driven system has to be evolved, has to be adopted, so that these waste materials can be considered usable material. Now this is called as a second time after using it, again it is going to become you are going to discard it and it is going to become a waste material. So again you are going to move on and on, and so this recycling of the material, reprocessing condition, or some technology driven system has to be evolved in order to convert this waste material in a usable material, which we call it as a, sometimes in terms of economy we call it as a circular economy, these sorts of material. And of course, in order to eliminate this waste material from the society, of course, lot many different programs and that scheme is being adopted by the government of India, then the state and municipal authorities as well. Let's say Swachh Bharat Abhiyan, Swachhata Bharat Abhiyan, and some sorts of things and something like that. So here, in terms of material, we have
Participants, please अपना mic off करके रखें.
हेलो
संजय गोयल सर.
हाँ गुरुजी.
So here you will be able to see.
बंद करिए अपना mic.
परम सम्मानी.
अपना mic बंद करिए संजय सर.
तो अभी हम लोग क्या किए, हम लोग के पास एक प्रिकर्सर मटेरियल था, फेवरेबल प्रोसेसिंग कंडीशन में उसको डाले मटेरियल को, and it is going to be converted into desired material for desired application. उस एप्लीकेशन को we have used it, primarily we have used it, और उसके बाद जो डिस्कार्ड किए उसको वेस्ट बोले. इस वेस्ट को if you are going to recycle by some technology driven system, after evolving some technology driven system, this entire mechanism is called as recycling of the material for different applications. So here we are going to focus on the second part, that after primary use of material by a human being or by a domestic, after domestic application, if you are going to discard it, that material is going to become waste. Now we are going to take this waste material as a precursor, and then we are going to reprocess it by applying some technology-driven system over there, and that material is going to become usable material now. So this recycling material two times, 3 times, or something like that, it comes under the category of recycling of waste material for any or the value addition of waste material.
Your presentation is interrupted, not visible. So can you share?
Presentation is not visible.
Can you share 1 second?
Okay, just a minute. Just a minute. Yeah, is it visible now?
Yeah, sir.
Okay. So
Yes,
by
sir.
now we have discussed about the material, cycle life of the material. अभी तक हम cycle life material का कहाँ से precursor लेते हैं, use करते हैं, favorable processing condition के द्वारा we convert it to desired material discard करने के बाद waste material बना. Waste material का कैसे recycling करेंगे? We are going to focus particularly on these topics as far as today presentation is concerned. Well, now categorization of waste. If you are going to categorize waste, so broadly, by and large, you can classify into 3 different categories, and it is self-explanatory that solid waste, liquid waste, and gaseous waste. And these are certain examples of the solid waste, such as glass bottles, crockeries, plastic container, metal, radioactive waste as well. Now again, you can further subclassify into biodegradable and non-biodegradable type of solid waste. So if you're talking about biodegradable means, so example is agricultural waste, food waste, paper. So biodegradable means it can be further disintegrated, or it can be disintegrated, and it is going to be mixed up in the environment, and it is not going to pollute the environment over there. So it comes under the category of biodegradable material or biodegradable waste, let's say. And second category is non-biodegradable. Just a plastic hai, metal hai, synthetic material, radioactive waste, and these come under the category of non-biodegradable. So if you are talking about solid waste, you can broadly classify into 2 categories, namely biodegradable and non-biodegradable. Biodegradable means you can degrade, you can further disintegrate it into a smaller chunk, and it can be again carbon and hydrogen form. It is going to the environment by one or another means liquid mode में पानी में करके it is going to become poisonous, and it's going to impact the human being, and in fact the entire your living organism your nearby, whatever is visible to you. Now second category is liquid waste, which particularly the major chunk, it is contributed by the industries, your wastewater, effluents of the industry, fertilizer and pesticide solution from the agricultural fields, which leachates from landfills, and finally you'll be able to see urban runoff or untreated wastewater, garbage, mining waste. So these are the category of liquid waste, and it may contain some non-toxic inorganic substances as well as toxic organic substances as well. मतलब जो liquid waste होगा इसके different sources हैं, and इसको बड़ी सब classify करना चाहे तो you can classify into non-toxic category and toxic category as well. So all that you need to do is that you have to treat these toxic organic substances by, of course, some technology-driven system has to be adopted, and you can convert it into some usable product, or some value addition has to be done in the system. Similarly, third category is gaseous waste. Of course, manufacturing industry, lot of many industrial, and after industrialization, we'll be able to see that in the environment in the form of a gaseous toxic gases coming out of the manufacturing unit. So during manufacturing, processing, material consumption, biological processes, etc., you'll be able to see some hazardous gases, some greenhouse gases, and particularly which includes carbon dioxide, monoxide, methane, chlorofluorocarbon, or it is one of the most major chunk which is depleting your ozone layer, which is protecting us from your different rays, and which is not useful for you. Some nitrous or nitrous oxide, or some oxide of nitrogen, NOx, which we call it as NOx. Some SOx, this oxides of sulfur, some models for that, so by adopting certain technological devices, we can take a for the proper control of gaseous waste in the environment. Now again, further classification from biological, chemical, physical, and their nature, you'll be able to see that you can classify into 3 different category, namely biodegradable. So already taken up some examples of biodegradable these waste material, which includes your natural organic compound degraded or decomposed by biological or microbial action, which is generated in food processing unit, cotton mill, paper mill, sugar mill, and different types of factories is going on, and it is biodegradable in nature. So waste of slaughterhouses is one of the most major chunk of biodegradable for these waste material. So skin is used to make shoes and something like that. Some example is given over there. We will take up in detail these biodegradable type of waste material, and I'll show you some of the technique which can be adopted by the physics materials to cover some value-added product. So mainly non-hazardous type waste is produced in this type of industry. Whenever you are talking about biodegradable waste, here we are talking about a non-hazardous type of waste which is produced in different industries. And some examples, we have shown certain examples over there in this block, biodegradable block. Second category is non-biodegradable. So it is not decomposed by either microorganism, or naturally it is not going to be degraded or not going to be decomposed soil or earth surface or scraps, sludges generated from colliery operations, refineries produced inert, dry solids and varieties of sludge containing oil. Some fly ash is a major solid waste from thermal power plant, and it includes tires, plastics, rubber product, and something like that. So we will take up some examples. And third category belongs to the hazardous waste material. So any chemical, biological, explosive, or radiation comes under this category. Are highly reactive and toxic in nature, and it poses a severe danger to human, plants, or animal life, or it is going to disturb your ecosystem to a very high level. So and lead, mercury, by leachating these lead, mercury, cadmium sorts of contaminants in your water, so that water is going to be toxic, and it is, you cannot use it for drinking purpose and something like that. So effluents and your dry rubber industries, you'll be able to see many hazardous materials are there, and some elemental waste which is not good for human health, and in the nano range you can inhale in your body, and it is going to block your stomach, and it is going to again create many problems to kidney and lungs, and different medical health issues you can suffer from these medical issues over there. So hazardous waste materials may be toxic, reactive, ignitable, explosive, corrosive, infectious, or radioactive. You'll be able to see, I have quoted some of the examples. So you'll be able to see when you're going to classify this waste material in terms of biological, chemical, and physical, and their nature as well. You'll be able to see you can classify into biodegradable, non-biodegradable, and third category is hazardous. We will in due course of time we'll be able to see that how to use it for different reuse it for different applications. Now, the effect of this waste material, if you're not, what is going to happen over there? What is the impact of this waste material in the society? So if you're not going to collect this material and allow it to accumulate in or dump it in certain chunk of land, if you're going to use it over there, the first and foremost problem it is going to create is your unsanitary condition is going to be developed, is going to be created over there in that nearby region of that chunk of land, whatever you are going to use it for accumulating this waste or collecting that waste. So that land is of is very, very your hazardous in nature over there, and it is going to create an environmental pollution. Health hazard issues comes into picture. It may lead to epidemic outbreaks as well. So I mean, 2-3 years back, you'll be able to see that entire world suffers that a pandemic situation. We have gone through that pandemic situation of this COVID. These are all just because of your mismanagement of this waste material. You don't have any proper method, you don't have any proper way to resolve this type of material, or to resolve such type of problems, to overcome with this hazardous or health effort, your health issues or environmental pollution issues, and it leads to different sorts of diseases like cholera, diarrhea, dysentery, plague, gastrointestinal diseases, and it may spread to the society, and it cause loss of human lives as well. And at certain stage, if its intensity is to that level, you'll be able to see that it is going to cause a loss of human lives as well. Now, what is the solution? Now, by now we have understood the definition of waste is basically a discarded material after primary use. So we have seen different types of waste material by now. Now, what are the solution? We have a waste in the society, in your nearby locality, in a local region. You'll be able to see many different waste materials are there. So how to overcome, or what is the mitigation of this? What is the mitigation of these problems? So most general and widely used concepts, it includes waste hierarchy. So this technique is called as, and is being adopted by the research community, by global community nowadays they are adopting these methods, that is, which we call it as a 3 R's technique. Sometimes it is called as 5 R's technique. So 3 R is basically reduce. First and foremost point is that try to reduce that waste material, try to reuse that material, try to recycle this material. So reduce, reuse, and recycle of the material is one of the way to mitigate this, and which we call it as a waste hierarchy. So it is also referred as 3 R's method. So reducing, reusing, and recycling is one way of that mitigating such type of issues over there. Now it remains the cornerstone of most waste minimization strategies. So the main aim of the hierarchy is to extract the maximum practical benefit from products and to generate minimum amount of waste in the society. So circular economy, you'll be able to see nowadays everybody is talking about circular economy. So if you're talking about a circular economy, so we have a source, we produce it, we sell it, we use it, we discard it. When you are going to discard it, either it goes in landfill, or you incinerate it, or you burn it in a big furnace. You put all those waste over there, you burn it, and again it is going to create a environmental pollution in the form of a gaseous pollutants comes out of it, in terms of carbon monoxide, carbon dioxide, and all these sorts of polluted gases comes into your environment, and again it leads to the greenhouse gas entering in the environment. So greenhouse effect comes into picture, and again is a major problem over there. So from your government action point of view, if you're talking about, so government is already framed certain waste management policies over there, which we call it as by different from time to time they have evolved different acts, and for example, Environment Protection Act 1986, Hazardous Waste Rule 1989, Biomedical Waste Rule 1998, Municipal Solid State Rule 2000, Waste Management Act 1996, Solid Waste Policy in India 2006, and something like that. Many different policies were already framed by the government, and it is in effect. But the point is that until and unless that common people is not going to awaken over there, and they are not going to utilize these policies, act in their day-to-day life, this solution, you'll not be able to come to some solution over there. So now here, before incineration, before landfill, after using, be able to see that some solution is being provided over there, that try to repair that material, try to reuse that material, try to refurbish that material, and then try to recycle those material at different stages. And in that way, after utilizing your value added product once, try to not directly discard to the landfill. Better to adopt either of the way. Of course, I'm talking about circular economy. A model may be adopted to mitigate such problems over there. Now, another concept is there, that which we call it as a 5R pathway to sustainability, and of course being adopted by United Nations and entire your research community working in the field of waste management. You'll be able to see 5R. 5R is meant for reduce, reuse, replace, recycle, and then reinvent. These are the five R pathway for achieving sustainability, and of course it leads to the, and it will strengthen your Envision 2030 your sustainable development goal in achieving sustainable development goal over there. So this 5R pathway, a 5R model, 5R method is one of the most third to mitigate this problems or solution. Now, if you're talking about refuse, so replace, don't purchase, and something like that. Reduce, cut back, reuse, use over and over and over again and again. Try to use it. Repurpose, repair, and do it yourself. Recycle, reuse materials as source, and something like that. So, and this is the on the left side. You'll be able to see the disposal, energy recovery, recycling, and some sorts of reuse and your minimization, prevention. These are some of the models. So this is called as the Apex model, 5R model. After utilizing this 5R model, you from bottom measure chunk, and at the top able to see that you are going for the green. It is called as the green, go green. Sorry. So go green. So waste management these are some of the waste management strategies. These are some of the waste management strategies which may mitigate your problems over there. Now, before coming to this slide, I would like to share this slide to you. So let's have a look on municipal solid waste. Municipal solid waste means which is coming out of your household, the waste which is coming out from your household. So that municipal waste or municipal solid waste, if you are going to characterize it into different chunks, you'll be able to see that 38 major chunk is 38.1% is being contributed by paper, board, and something like that. Thank you. And now, apart from paper, board, and something like that, you'll be able to see there is a yard waste, and its contribution is 13.4% or something like that. Metal related or in refineries, you'll be able to see that some wastes are 7.7%. It is the contribution of metal waste. Plastic waste is 9.4%. Food waste is 10.4%. 5.9% is glass waste. Wood waste is 5.2%, and other is 9.9%, something like that. So when you are going to club it, means your paper and your yard waste, your food waste, your wood, if added, so it comes out to be something 67% to 70% or something like that. And that is what it is written over there, that about 67% of the total municipal solid waste is contributed by one or another type of bio waste, which includes your paper, paperboard, wood, food waste, yard waste, and something like that. Now, again, the problem is that is the global scenario, that 20% of the municipal solid waste is processed and is being used for recycling purposes. And what about rest of the 80%? Rest of the 80%, it is dumped in the landfill, and which leads to a serious pollution in the environment. So, and again, we have seen that in municipal solid waste, 67% to 70% of the municipal solid waste is being contributed by one or another type of bio waste. So here we are going to discuss about the recycling or reusing or refusing of this bio waste material to value added product. And we are going to discuss about the technology driven system being adopted by our research lab to convert this bio waste material to value added product. And that value added product is going to be contributed in the field of renewable energy, water treatment, your waste management as well, your circular. It is going to strengthen your circular economy and lot many different amalgamated form of the utilization of bio waste to value added product. Now it is very efficient, it is a cost effective, it is environment benign and sustainable. The state of the art is explored by recycling or reusing of this bio waste, or for its valorization or for its value addition. So here we are going to discuss about the utilization of these bio waste material for specific application, and of course for renewable energy application. So here waste material is by one or another different separation mechanism is there. You just separate it and just take all this bio waste material in a chunk of container, and then we are going to discuss about the recycling or reusing of these bio waste material to wealth. From wealth point of view, it is going to contribute in earning certain money or some in economical contribution as well. These waste management strategies we are going to discuss about it. Now, why biomass? Why biomass? How biomass is going to contribute in the, so you'll be able to see that biomass, whenever you're talking about biomass, it is a recycling, it is a biodegradable in nature. It is in this way. On the left hand side, you'll be able to see, as we know, we inhale oxygen, it goes in the blood, it is going to again produce certain energy, water, and then going to convert it into a carbon dioxide, and you exhale carbon dioxide. Means we inhale oxygen, we exhale carbon dioxide, and in between we are getting certain energy out of it, and which is very essential for a human being. Now you'll be able to see, we inhale oxygen, we exhale carbon dioxide. On the other hand, these your biomass, what exactly biomass does, in presence of sunlight, the chlorophyll is going to present in your these leaves and different biomass, chunk of the flowers and a chunk of the biomass. The chlorophyll in the biomass, after taking sunlight, or when sunlight is incident on that, it is going to convert into a glucose, and then it is going to utilize carbon dioxide well. Means in presence of sunlight, carbon dioxide plus that chlorophyll present over there, and then water in present in your atmosphere, or your, let's say, from groundwater, it is going to take groundwater over there and convert, and it is going to convert into your energy, glucose or something like that. And this process is called as photosynthesis. And again, apart from that glucose, oxygen is being liberated by these leaves or biomass material. So biomass is one of the most important chunk for living being, human being, and that's why try to plant as many as trees for your coming future, so that more and more natural oxygen is liberated in the environment, and you are going to utilize it for your necessities of life. And then it is going to, whatever exhaling, these biomass is inhaling it, whatever you are inhaling, it is exhaling it. So you'll be able to see that complete cycle is going to be completed over there. That biomass is essential for your living being as well. So that's why we are going to plant as much as biomass, so that biogenic biocarbon is utilizing carbon dioxide, whatever you are exhaling. If after utilizing it, it is providing you, it is producing it providing you certain energy, means your leaves or plants, whatever you are eating it for your day-to-day life. So that biomass from that point of view as well. And when it is discarded after using it by you people, once you have utilized this biomass, so again it is going in the environment, it is leaching in the environment, and it is going to pollute, because carbon is going to be converted into either carbon monoxide or carbon dioxide. If you are going to landfill it at certain point, then you will be able to see that it is going to be converted either into mass gas, means let's say methane gas, carbon dioxide, carbon monoxide, and it leads to the your again pollution in the environment, greenhouse gases, and that we call it as green gases. So here there is a net zero concept. So net zero concept means we are planting these trees and all that. After converting it into energy, we are eating it by one or another mode. We are utilizing this energy, and after discarding it, it is going to become waste for you. If you are going to utilize that waste, if you are going to value add that particular waste, so this you'll be able to see that circle, that cycle, entire cycle is going to be completed. So this we call it as a neutral biomass carbon cycle. So that it is not going to produce any sorts of pollution in the environment. That's why it is called as a net zero concept. So it is going to maintain a balance between greenhouse gases being produced in the environment, and it is going to remove that greenhouse gases from the atmosphere, because it is going to utilize it, it is going to use it, it is going to inhale it for converting it into energy and something like that. So some flow chart is given on the left bottom on the left corner, you'll be able to see. So these are 3 different routes for the decarbonization, and I'm going to discuss over there. So now how to proceed further. So here what we are going to do is that you are going to plant different types of your trees and all that. It is going to be converted into waste. You are utilizing it for eating purpose, as a food, whatever you are discarding it, you are going to choose that bio waste. It includes your agricultural waste, it includes your trees, it includes your coconut shell, it includes your orange peel, banana peel, and something like that. Whatever biomass you can think of, we can utilize those biomass, we can utilize those plastic waste, and then we are going to convert into a value product. That is what we are going to do. Now, these are some of the bio waste treatment flow chart that direct use, how biomass can be directly, you can use it. So direct your land application, direct animal feed, direct combustion, and something like that, meat, fish production, and something like that. Then biological treatment, how you are going to treat this waste material. That composting method is there, vermicomposting method is there, dock solder, fly treatment is there, anaerobic digestion is there, fermentation is there, by which you are going to convert it into bioethanol for transport as a mode of transportation over there. You can utilize it. You do it for cooking fuel, heat, electricity generation, and something like that. Third chunk is physical chemical treatment. You can first classify into esterification method, densification. You are going to convert it pellet, briquette, and for cooking purpose, you can use it. Esterification purpose, if you are going to use waste material, you can convert it glycerol, biodiesel, and again for transportation as a transportation fuel, we can utilize. Now, last but not the least is thermochemical treatment method, where you are going to pyrolyze it. Pyrolyze it means you are going to burn it, this biomass material, under certain condition, and then it is going to convert into again 3 different chunks. So you'll be able to see thermochemical treatment method means chemical, either by some chemical reaction or by putting some thermal temperature over there, so that at a higher temperature it is going to be dissociated into its carbon and different functional group going to be utilized in pharmaceutical. So pyrolyze it, you can liquefy it, you can gasify it. So different models or different chemical method convert that into a gaseous state. Liquefaction method means you are going to convert into a bio oil. Pyrolysis means when you are going to burn these biomass material in certain furnace. Those furnaces are there. If you are going to burn it into certain, if you are going to put it into certain furnaces at higher temperature, of course you know it. If you are going to burn some carbonous material, it is going to convert it into either carbon dioxide, and finally it is going to convert into ash, and that ash is of no use to you. All you can do is that at higher temperature, under controlled environment, means just try to eliminate oxygen out of it. So some research groups, they are utilizing nitrogen, one of the mode to eliminate oxygen from the environment. Means local solid, liquid, and gaseous chunks. If you are going to heat it, if you are going to burn it, so you are going to get three different chunks. One is called as solid, another one is oil or liquid, and third one is gaseous. When it is in a solid form, we call it as a char. Char means sometimes it is also called as a charcoal. You have converted bio waste to char. That's why it is called as biochar. Sometimes it is also called as a biocharcoal and something like that. And another one is the biodiesel or bio oil, and it is utilized in transportation field or transportation sector. Third one is the gaseous phase. Of course, here we are going to elaborate it further. That gaseous, the composition of gaseous phase, how you can treat this, scrub it, your notorious element over there, and finally after scrubbing, you can convert it into a value-added product. So waste to wealth, pathway to renewable and sustainable energy is something like that. So here we have chosen bio waste. That bio waste, we can consider this bio waste in two different categories. Number one, wherein moisture content of that biomass is less than 20%. Another chunk is where moisture content is more than 20%. So broadly, that bio waste can be classified into two different types. Where first category is wherein moisture content is less than 20%. Second category is where moisture content is greater than 20%. Now, how to treat biomass having moisture content greater than 20%? So that process is called as biochemical conversion route. So biochemical conversion route means, of course, you are going to put that material in some microorganism or some microbes. You are going to put it over there. It is going to utilize your methane and these sorts of material over there, and going to be converted into your value-added product like organic manures and something like that. Second, and of course, when you are going to treat these bio-waste material using biochemical conversion route, it is going to be converted, and so the major chunk of that gaseous, and earlier we call it as a biogas. हम लोग जिसको गोबर गैस प्लांट एंड ऑल दैट वी कॉल इट, हम लोग पहले कहते थे गोबर गैस प्लांट वगैरह में, वो फेलियर मॉडल था बिकॉज़ इट इज स्मेलिंग लाइक एनीथिंग, कुकिंग में बहुत ज्यादा यूजफुल नहीं था, उसकी एफिशिएंसी कम थी एंड समथिंग लाइक दैट. बट नाउअडेज लॉट मेनी एडवांसमेंट इन द टेक्नोलॉजी कम्स इनटू पिक्चर. So that biogas का major chunk, 60% of the biogas is methane, and 35 to 37% is carbon dioxide, and rest of them is different your contaminants is there. And another that solidus part is called as organic manure. So you can spread this organic manure in your for cultivation purposes in your field, and then fertility of the field, you can enhance it in that particular manner. And that biogas can be after a scrubbing mechanism. If you are going to scrub carbon dioxide out of it, then finally you are going to get a methane, and that methane is called as biomethane. So biomethane, you'll be able to see bio CNG whenever you're talking about. So in bio CNG, more than 92% is methane, and just other nitrous or sulfur dioxide sorts of gases are there. Now another route is thermochemical conversion route, wherein moisture content is less than 20%. If moisture content is less than 20%, you burn it, under certain controlled environment. And again, you'll be able to see that it is converted into three different chunk. One is solid, another one is liquid, third one is gaseous. Solid is called as biochar, and 20 to 25% is you are going to get when you are going to burn any biomass material. So 20, you are going to get all three components, sometimes all three components, sometimes only one, sometimes two, sometimes mix up of all three. So by and large, when you are going to burn bio-waste material having moisture content less than 20%, then in certain furnace, of course in a nitrogen environment at higher temperature, you are going to get solid, which you call it the biochar, and its composition is 20 to 25%. You are going to third one is gaseous state, which is one of the most important counterpart of these thermochemical conversion route. And these gases, whenever you are talking about these gases, the composition of these gases is something like that. It consists of hydrogen, methane, carbon monoxide, and carbon dioxide, and its content is 35 to 45%. Now, further, let's elaborate the thermal chemical conversion route by this slide. I think it is very useful slide for you people. How you can convert this biomass waste or bio waste material into a value-added product. Now, this slide says a lot. Now here, this is a method. This is a feeder. You just put your bio-waste material in this feeder having a moisture content less than 20%. Go for thermochemical reactor. Thermochemical reactor means some furnace, big furnace, and something like that in a controlled environment. And when you are going to burn it, what you are going to get? You are going to get solid biochar. You are going to get pyrolysis vapor. That pyrolysis vapor, further you can treat it. It is going to convert it into bio oil, and that bio oil further after treatment you are going to convert it into diesel and bio oil here. Now, after entering in pyrolysis vapor, some of the chunk is going to be converted into bio oil, and rest of the is going to be converted into steam, and that is going to convert it into a gaseous state. And here condenser is there. When you are going to apply condenser across this pyrolysis vapor container, you'll be able to see after condensing, liquidous phase is going to convert it into bio oil, and that your gaseous phase is going to move in this particular container, and this gas is called as syngas, and sometimes it is also called as synthetic gas. Synthetic gas composition is hydrogen is 70%, methane is 12%, carbon monoxide 4%, and carbon dioxide 4% again. Now, if you are going to further scrub it, अगर आप इसको scrub करते हो synthetic gas को, scrubbing mechanism means what? If you are going to remove carbon monoxide, carbon dioxide, and उसको remove करेंगे lot many chemical. Hello, somebody is saying something?
No, sir. Please go ahead.
हाँ, तो अगर इसको हम लोग further treat करेंगे, if you are going to treat further this synthetic gas, so इसमें carbon monoxide, carbon dioxide अपने काम का नहीं है. Scrub it मतलब सब chemical reaction करा के carbon monoxide को water shifting reaction, बहुत सारे reactions वगैरह हैं जो carbon monoxide को utilize कर लीजिए आप कहीं. Try to utilize carbon dioxide somewhere, or some scrubber. There are not many scrubbers are available in the market. You scrub carbon monoxide by a separate scrubber, carbon dioxide by a separate scrubber. Then you are going to get, ultimately you are going to get hydrogen and methane. Now sometimes this hydrogen and methane, they are use it in different ratio, and which we call it as a high-cane gas. Here we will discuss it at later stage. So here what you are going to do, suppose simply you are utilizing this synthetic gas. How can you utilize this synthetic gas for any value addition or for any purpose? So see, if you are going to utilize this synthetic gas, to run a turbine, and till today, as far as electricity production is concerned, so thermal power plant, what exactly it does? So you burn coal, you heat water, you convert water into a steam. That steam is going to rotate your turbine, and that turbine, in presence of magnetic field, it is going to convert it into electricity and something like that. So that's how till now, till today, the way to get electricity from either from thermal power plant and similarly from hydro power plant, what is going to happen over there? You have a dam, you store water over there, potential energy of the water, and that water is falling from very at certain height. It is going to fall on the turbine, and that turbine is going to rotate it over there. You are going to put magnetic field across it, and then that in presence of magnetic field, of course, Faraday's law of electromagnetic induction comes into picture. So in X direction, turbine is moving, Y direction, you are applying magnetic field. So in Z direction, electricity is going to be produced over there. This is the only way to get electricity, and till today, this Faraday's law of electromagnetic induction is being utilized in electricity generation over there. So here, instead of using steam to run turbine, you can utilize this synthetic gas, of course, after scrubbing it, after removing this carbon monoxide, carbon dioxide, and some other contaminants over there. Otherwise, it is going to destroy your turbine, that plate, and something that some rust is going to take place, and then in due course of time, so that is going to deteriorate it. So after scrubbing it, synthetic gas can be utilized to run turbine, and turbine, after running turbine, it is going to convert it into electricity. Just feed it into your substation, and finally our distribution system is being applied to distribute it in different household and for commercial application. Now another way is that you can utilize this electricity. You'll be able to see in this particular part, you can utilize this electricity directly to electrolyze this water, and that water is going to be splitted into, and that simple Faraday's law of electrolysis comes into picture, and this water at certain ambience condition is going to convert into hydrogen and oxygen. You store hydrogen, you store oxygen. So oxygen is very useful for human life, and this hydrogen, you utilize this hydrogen in hydrogen based fuel cell or hydrogen based nowadays that vehicles comes into picture. So you can utilize this hydrogen for different commercial application. Similarly, here that synthetic gas, by using a cryogenic separation is in a very lower temperature region, what you are going to apply some ice or some refrigeration condition, you are going to apply it over there. So depending on the boiling point of the gases, it is going to and just take it away from different some attachment has to be added over there. So carbon dioxide, carbon monoxide, methane, and hydrogen. So by using cryogenic separation, hydrogen, carbon monoxide, carbon dioxide, methane can be separated from synthetic gas using cryogenic separation. This is one of the way to separate these hydrogen, methane, and all these gases over there. Another technique is pressure swing adsorption technique is being adopted, wherein you can utilize this synthetic gas on this pressure swing equipment set or that instrumental setup. So it is going to convert it to hydrogen gas over there, and that hydrogen gas is a natural gas and pipeline, and using methane and hydrogen. Nowadays there is one terminology called as a hythane gas. So there is a report of IOCL, when you are going to add 18 to 20%, or let's say maximum 25% of the hydrogen in methane, that mixture gas is called as hythane gas, and efficiency of the engine, internal combustion engine, can be enhanced, and with the help of this pictorial diagram, effect of hydrogen and tank volume, and this is CNG. It runs 300 kilometer, hydrogen runs 300 kilometer, hythane runs 300 kilometer. So 1.2 times more volume is required over there. Here 4.5 times more volume is required, and here that CNG tank is something like this. So you'll be able to see the improvement in the engine efficiency of the engine can be utilized by using this particular hythane based technology. You can use it. Now you can utilize hydrogen gas in a hydrogen fuel cell. One side hydrogen is coming, or sometimes it is called as a proton exchange membrane fuel cell. So one side hydrogen is coming as a input, another side oxygen is there. Hydrogen with some porous material is there. Hydrogen is mobilizing or migrating from one end, or hydrogen is going to be converted into 2H plus and 2 electron. That 2 additional electron is coming out from the external circuit. You can you can draw that electron from the external circuit for utilizing it as a power load or something, that you just put some load over there. So that electron is going to provide current to it, and that hydrogen ion is going to mobilize from this end to this end. Here it is going to react with oxygen, convert it into water, and this from this side electron is coming, and that electron is going to reduce this oxygen over there, and then it is going to convert into hydronium ion. And in the way that proton is going to move from left to right, right to left, and something like that. And by giving you some electron, and that electron is again you are going to get current out of it, and then you can run that whatever vehicle you can think of. Now another way is that if you are going to utilize this hydrogen as a fuel, they nowadays hydrogen fuel based vehicles are also in the market, so you can directly utilize hydrogen as a fuel in this transportation sector. Now this part, diesel and bio oil, now this biodiesel can be utilized to run your diesel based vehicle. Now another part is biochar. If you are talking about biochar, many different applications of these biochars are there. You can convert it into a briquette, which is a charcoal briquette. You can directly use it or utilize it in place of coal. You can directly utilize charcoal briquette for heating purpose. You can treat this biochar using different techniques, which we call it as a physical and chemical activation technique. When you are going to treat this biochar, either by physical way or chemical way, by activation way, it is going to convert it into either activated charcoal, or if you are going to pyrolyze it, or impregnation method you are going to adopt it, hydrothermal you are going to adopt it for treatment purpose, it is going to be converted into either graphene quantum dot, carbon quantum dot, or graphene oxide, reduced graphene oxide, and something like that. You can utilize this activated charcoal for water treatment. You can utilize this graphene, carbon quantum dot, graphene GQD, graphene oxide, RGO for this water treatment purpose. You can utilize this activated charcoal for energy storage application. Which includes your supercapacitor, lithium battery, solar cell as well. We are utilizing activated charcoal or graphene based material or graphene oxide as a counter electrode in your solar cell. Disensitized solar cell is being fabricated using this material over there. Also, many different applications you will be able to see from this particular slide. And yeah, another component, another chunk is having moisture content is more than 20%. Just put it in anaerobic digestion. Anaerobic digester means here, in absence of oxygen, that chemical reaction is going to take place. So it is going to convert it into organic manure, spread it into field to further make your more fertile. And that biogas, again, 60% methane, 35% carbon dioxide. So you scrub it, convert it into bio-CNG, again use it in the transportation sector. So here you will be able to see waste to zero or bio-CNG, conversion of bio-waste to bio-CNG is feasible. And here I have shown the comparative study of bio-CNG and CNG. You'll be able to see is CNG as compared to CNG, bio-CNG is better fuel, because here you'll be able to see the major chunk is methane, which is 93% in CNG, and then another nitrogen and carbon dioxide and other ethanol is there. Either at par or better than CNG. IOS to bio more than 20% is one of the most upcoming field as from research point of view. So you can go for a pilot project, and some companies are still there. Is some startups come there. Some recently they have started this startup for this conversion of this part, hydrogen gas, CNG, and sorts of things by using this thermochemical conversion route. Biomass, moisture, less than 20%, means basically they are utilizing rice husk, your wheat straw, and plastic waste can be converted into these either graphene allocation. So in our research, we are converting this biochar physical activation method to activate charcoal, graphene, quantum graphene for its application either energy storage and conversion devices like battery, supercapacitor, and dye-sensitized solar cell. So I'm going to show you some results in another slide. So can you please tell me how much time is still how time people are going?
Sir, we have not much time, but we will get you 10 minutes.
10 minutes, I'll try my level best to wind it up. Now, if I'm in the last slide, I have about this chemical activation method. So by and large, what physical and chemical activation method, I would like here it's so this activated charcoal we can convert charcoal into activated charcoal by physical activation and chemical activation method. What is physical activation method? Physical activation method is the gasification carried out at a higher temperature in a range of 700 degrees Celsius in presence of some oxidizing agent. Some oxidizing agent like let's say your carbon dioxide or something like that for physical activation. In presence of steam, you can heat it and gasify it for physically activate it to get activated charcoal. Chemical activation, it is carried out at a lower temperature and in a range of 400 to 700 degrees Celsius in presence of certain catalyst. And here the catalyst, what we are using it something like OH or H3PO4, these sorts of some catalyst we are going to utilize it and add it up over the again, and by adopting certain process, we are going to convert it into activated charcoal and graphene based material by the temperature in a range of 400 to 700 degrees Celsius. So that is the basic difference between physical and chemical activation method. So here I'm going to show some results. We have chosen mango kernel. Again, we have worked on biomass and we have utilized algae shell. We have used sugar cane, bagasse, what we call it as a coconut shell. We have utilized wheat straw, rice husk, and lot many different bio waste material we have utilized it. Here I'm going to show you the results based on mango kernel. So aam ka jo gutli hota hai na, gutli. So we have chosen that material for converting it into. So aam ke dinon mein nowadays in summer days you will be able to see lot different everywhere mango, everywhere mango is there. So आम का गुठली उठा के हम लोग फेंक देते हैं and that गुठली is going to again environmental pollution. It is going to create lot many environmental pollutions over there. So उस गुठली को लेकर के and we have again taken some electrolyte, that is let's say CH3COONA and some efficiency or oxide additive we have chosen. Why we have chosen in discuss it. So here we have chosen mango kernel. We have adopted that mechanism, physical and chemical method, means here particularly we have adopted chemical method. We have converted into activated charcoal. That the effective surface area of activated charcoal, which is the size from mango kernel, is about 1.3 meters square per gram or something like that. And with this material as an electrode material and this CH3COONA and K4 efficiency 6 as a electrode, we have fabricated supercapacitor devices. And what we got, what we observed, that per gram by utilizing K4 efficiency 6, which we call it as redox additive to this electrolyte. So without redox additive, we are getting capacitance of 92 farad. With additive, we are getting capacitance of 197 farad per gram. And the energy density is respectively 7.1G, you will be by adding this redox additive as well. So the physics or the science behind this is some reaction and all that is there. I'm doing details of that. In a nutshell, to say is that we have this mango kernel that utilized for the fabrication of supercapacitor, and we got these results, and we also 5,000 capacitor devices. So it's like 200% in different journals. So that XRD pattern shows that, and that corresponding to 2 theta 20 degree before spaces we synthesis of activated charcoal using XRD method, and this is run where the ratio of this identity comes out to this 0.9 activated charcoal is being confirmed. These are some of stem graph porosity being developed in this material. So these you'll be able to see that in different resolution being shown there. So this is a porous image and having effective surface area greater than your 130 meters per gram or something like that. For utilizing it as a electrode devices, and these are the these are the average diameter of pore size. These pore size average 3.81 millimeter. It comes under category mesoporous. By nature, different types can be you can characterize where if size is by 2 nanometer, call it as porous material, then porosity lies in between 2 and we call it as porous. Capacitance, supercapacitor. So here supercapacitor we have created. So this is my kernel based without it. Either side we have capacity 0.24 K6. Why 0.24 0.2 molar K4 efficiency? Because it's and these are the pattern we are going to get. So I'm not going into the in these of course I'm not going in details of that because the profile and these are the electrode material which we have and the test. So the model evidence event reactive part, and these are the for 5,000 cycle and this still so you come into activated carbon for the not like so we are very choosing plant-based biomass. So how to choose? So you have to choose the biomass having a high liquid fraction, low cellulose fraction, low oxygen fraction, high nitrogen content, and things like that. It facilitates in obtaining derived carbon with high yield, higher utilization, controlled defects, and good conductivity, which is desired for the high performance of capacity, supercapacitor material. So here, calculation is mass ratio between activating reagent and carbon feedstock, temperature, time of activation process. These are some of the parameters by which you can control it. So here the mixture is thermally treated at duration of half an hour to 2 hours. Slow heating rate. If you are going to increase the rate again, is going to take place. These are the ratio in which you are going to mix activating agent, and is the pressure range, the activating agent ratio, and that's how you're able to see that low KOH and C mass ratio is of the order of 1. Activation induced the mesopore in the range of 5 nanometer of the carbon feedstock, and it is very useful for supercapacitor. So these are some of the summary of the other biomass based supercapacitor. So we have taken treated activated charcoal, eucalyptus based activated charcoal, coconut shell, almond shell, sugarcane waste as the activated charcoal, and these are some of the results. These are some of the electrolyte system which we have chosen for supercapacitor fabrication, having these results. So of course, I have tried my level best to share some of the results and how to convert this bio-waste material to a value-added product. And if some questions are there, I can take it up. Otherwise, thank you very much, all of you.
Questions? Thank you so much, sir, Professor S.K. Tripathi, sir, for your enlightening.
Thank you so much. Thank you so much for your kind presence. Once again, I would like to thank the entire organizing committee, Department of Physics, your conference, webinar embassy, your principal, madam, everybody. I would like to congratulate you. I would thank everybody from bottom of my heart. Thank you. Thank you so much, all of you.
Thank you.
So now may I leave?
Yeah, sir, please.
Okay, thank you.
Before we go to our next speaker. We have short notice for participants who will present their presentation. We have received lots of presentation, but sorting won't appropriate for presentation. First, Dr. Paramjit Kaur, second, Dr. Amit Kumar, and third, Vindhya Srivastava. Please be ready after our second speaker lectures. To continue our journey of learning, let us invite our next speaker, Vijay Misra, sir. Sir has academic and research experience of more than 20 years. He has published several research papers in international and national journals and conference proceedings. Now,
thank you, Sandeep ji. आवाज आ रही है?
हाँ सर, आ रही।
तो सबसे पहले सभी को नमस्ते, और इतना अच्छा वेबिनार कराने के लिए मॉडल साइंस कॉलेज रीवा की ऑर्गेनाइजिंग कमेटी कन्वीनर को बहुत शुभकामनाएं। और क्योंकि अटल बिहारी वाजपेयी हिंदी विश्वविद्यालय को रिप्रेजेंट कर रहा हूँ, इसलिए मैं हिंदी में बोलने का, तो मुझे लगता है किसी को कोई समस्या होगी ना हिंदी में?
नहीं सर, किसी कोई समस्या नहीं।
तो आज का मेरा जो टॉपिक है लेक्चर का, वो कॉमन सा टाइप एक लेक्चर है जिसको हम लोग हमेशा यूज करते हैं, लेकिन तो कहीं न कहीं छोटी छोटी गलतियां हम लोग करते हैं। तो उन गलतियों की तरफ आपका आज मैं ध्यान आकृष्ट करा कि हमको कितना ये इसमें जो हम क्लियर होना चाहिए। तो अब मैं अपना जो प्रेजेंटेशन है उसकी स्क्रीन आपके सामने प्रेजेंट कर रहा हूँ। तो आप लोग देख पा स्क्रीन में?
हाँ सर।
जी सर।
ओके, थैंक यू थैंक यू। तो आज का जो टॉपिक है यूज ऑफ स्टैटिस्टिकल टेक्निक्स इन रिसर्च। जैसा मैंने बताया कि हम लोग भी किसी भी प्रकार का रिसर्च चाहे जिस फील्ड में भी करते हैं, निश्चित रूप से हम वहां पर कोई न कोई स्टैटिस्टिकल टेक्निक्स को यूज करते हैं। तो उन स्टैटिस्टिकल टेक्निक्स को कहाँ पर यूज करना, किस प्रकार यूज करना, और उनको यूज करते समय हमको कौन कौन सी सावधानियां रखनी चाहिए, इसके थोड़ा संक्षेप में मैं आज करूंगा। स्टैटिस्टिकल मेथड्स, जैसा कि आप जानते हैं कि विभिन्न प्रकार के रिसर्च में हम इनको यूज करते हैं। वो चाहे हमारे रिसर्च की प्लानिंग हो, चाहे रिसर्च के लिए डेटा कलेक्शन हो, उसकी एनालिसिस हो, और उस एनालिसिस के बाद उसके मीनिंगफुल इंटरप्रिटेशन जो हम प्राप्त करते हैं, और उस इंटरप्रिटेशन को फिर हम रिजल्ट में कन्वर्ट करते हैं। तो इन सभी विषयों में हमारे जो स्टैटिस्टिकल मेथड्स हैं वो काफी इंपॉर्टेंट है। तो इस प्रकार से हम कह सकते हैं कि जो हमारी स्टैटिस्टिकल एनालिसिस है वो मीनिंगलेस नंबर्स को मीनिंग प्रोवाइड करती है। जैसे अगर मैं उदाहरण के लिए बात करूं, तो अगर 5 बोलते हैं 5, उस 5 का कोई अर्थ नहीं होता, लेकिन अगर हम ये कहें कि द एवरेज हाइट ऑफ दिस क्लास स्टूडेंट्स इज 5 फुट, देन इट हैज ए मीनिंग। तो जब हमने वहां पर स्टैटिस्टिक्स एक लगाई एवरेज की, तो उस एवरेज ने हमारी उस संख्या को, जो नंबर 5 था, उसको एक मीनिंग प्रोवाइड किया। तो इस प्रकार से हम किसी भी मीनिंगलेस नंबर को मीनिंग प्रोवाइड करके और लाइफलेस डेटा के ऊपर लाइफ डाल सकते हैं। इस लेक्चर में विशेष रूप से मैं आग्रह करूंगा हमारे जो रिसर्च उसको वो लोग ये जरूर थोड़ा ध्यान से सुनने का प्रयास करेंगे। इसमें हमारा जो लेक्चर है वो उसके जो मुख्य टॉपिक्स हैं वो मैं थोड़ा आपको बताता हूँ। तो इस लेक्चर में हमारा जो पहले सोशल टेंडेंसी के बारे में बात करूँ, उसके बाद रिग्रेशन, क्वालिटेटिव वेरिएबल्स, क्वांटिटेटिव वेरिएबल, डाटा के डिस्ट्रीब्यूशन के बारे में। तो इस प्रकार से जो डिफरेंट टॉपिक, तो चलिए शुरुआत करते हैं डिस्ट्रीब्यूशन से। तो कुछ नंबर्स अगर रखे हुए हैं आपके पास, और इसको हम लोग हिंदी में बोलते हैं कि जब उस डेटा का हम वर्गीकरण करते हैं, तो उस वर्गीकरण के लिए हम लोग कई प्रकार की जो इम्पॉर्टेंट टेक्निक है दैट इज कॉल्ड डिस्ट्रीब्यूशन। तो यहाँ पर आप एक एग्जाम्पल नंबर्स लिखे हुए हैं 22, 20, 18, 28, 20 इस प्रकार से। तो ये जो नंबर्स है वास्तव में ये दुकानदार किसी अखबार वाले के विभिन्न दिनों हुई है। तो हमको अगर स्टैटिस्टिक्स में एक फ्रीक्वेंसी डिस्ट्रीब्यूशन ग्रुप में रिप्रेजेंट कर रहे हैं तो आप देख रहे हैं कि नीचे एक टेबल दी हुई है जहां पर पेपर सोल्ड लिखा हुआ है और फ्रीक्वेंसी लिखी हुई है। तो अगर हम पहली लाइन को देखें तो 18 लिखा हुआ है और उसके आगे 2 लिखा हुआ है। तो इसका अर्थ ये इस को ही देख करके बता सकते हैं कि 18 जो पेपर सोल्ड किए गए, बेचे गए, वो कितने दिन में थे? 2 दिन में। यानी 18 पेपर 2 दिन सेल हुए, 19 पेपर किसी दिन सेल नहीं हुए इसलिए 0 लिखा हुआ है, 20 पेपर 4 दिन हुए। इस प्रकार से इस टेबल को देख करके हम लोग बता सकते हैं कि आसानी से देख करके, और इसको समझाने में भी आसान होगा, तो हम लोग ये बता सकते हैं कि कितने न्यूज़पेपर हैं, कितने दिन। अब इस फ्रीक्वेंसी डिस्ट्रीब्यूशन को अगर हम एक ग्रुप फ्रीक्वेंसी डिस्ट्रीब्यूशन को जैसे 19, 20 to 24 and 25 to 20 फ्रीक्वेंसी हो गई 2 से 25 के बीच में 7 और इसका जो लास्ट है वो 29 तक में उनकी संख्या 1 है। तो इस प्रकार के जो डिस्ट्रीब्यूशन हम 6 में करते हैं उसको ग्रुप डिस्ट्रीब्यूशन। अब इस फ्रीक्वेंसी डिस्ट्रीब्यूशन को हम कंटीन्यूअस फ्रीक्वेंसी डिस्ट्रीब्यूशन में भी चेंज कर सकते हैं। अब कंटीन्यूअस फ्रीक्वेंसी डिस्ट्रीब्यूशन का मतलब क्या हुआ? यहाँ पर आपको कोई गैप नहीं दिखेगा, इंटरवल में आपको किसी प्रकार का गैप नहीं दिखेगा। यानी पहला इंटरवल अगर 0 to 5 है तो दूसरा इंटरवल 5 to 10 होगा, तीसरा 10 to 15, देन 15 to 20 एंड सो ऑन। लेकिन अब यहाँ पर जब हम लोग डिस्ट्रीब्यूशन करते हैं तो ध्यान हमको क्या देना चाहिए? कभी हम लोग यहाँ पर छोटी सी गलती करते हैं, 0 से 5 का हम इंटरवल लेते हैं तो हम लोग क्या करते हैं कि 5 वाला जो है उसको भी इसी में शामिल कर लेते हैं। अर्थ क्या है? बिलो 5 है ना, यानी 5 जो आएगा वो अगले वाले में आएगा 5 to 10 में। तो 0 to 5 में हम 0 से लेकर के बिलो 5 लेंगे, 5 to 10 में क्या लेंगे? 5 और मोर देन 5 एंड लेस देन 10। सिमिलरली ग्रेटर देन 10 एंड लेस देन 15, ये 10 to 15 होगा। इस प्रकार का जो फ्रीक्वेंसी डिस्ट्रीब्यूशन होता है उसको हम लोग कंटीन्यूअस फ्रीक्वेंसी डिस्ट्रीब्यूशन कहते हैं। इस प्रकार सामने तो इस प्रकार के टेबल को ग्राफिकल रूप में रिप्रेजेंट करने की सारी मेथड्स है। और उसमें बने हुए होते हैं। तो मतलब हाईएस्ट बार जो होती है वो क्या करता है? हाईएस्ट फ्रीक्वेंसी डिस्ट्रीब्यूशन रिप्रेजेंट करता है। जैसे एग्जांपल के लिए यहाँ पर जो हाईएस्ट फ्रीक्वेंसी डिस्ट्रीब्यूशन है वो कौन सा दिख रहा है अपने को? 50 to 60। मतलब इसका ये हुआ कि 50 to 60 रेंज हमारे मैक्सिमम डेटा जो है वो 50-60 के रेंज में फॉल कर रहा है। तो इस प्रकार का जो डेटा रिप्रेजेंटेशन है उसको ग्राम कहते हैं। इसी प्रकार से बार ग्राफ क्या करता है? ये डिफरेंट कैटेगरीज को कंपेयर करता है। ठीक है, तो हमारी जो डेटा की डिफरेंट कैटेगरीज होती हैं, यहाँ पर कुछ एग्जांपल दिया हुआ है, नीचे मंथ लिखे हुए हैं और ऊपर कुछ नंबर दिए हुए हैं। तो ये नंबर्स एक्चुअली क्या है कि डिफरेंट मंथ्स में जो आइसक्रीम सेल की गई है उनकी संख्या दी हुई है। तो यहाँ पर हम देख सकते हैं कि ये संख्या सबसे ज्यादा, अगर हम इस ग्राफ के अकॉर्डिंग कहें तो ये जुलाई महीने में सबसे ज्यादा आइसक्रीम सेल हुई है। तो इस केवल ग्राफ को देख करके ही हम बता सकते हैं कि उनकी संख्या कितनी है, लगभग यहाँ से पता चल जाएगा अपने को, और वो हम सीधे ग्राफ के माध्यम से बता सकते हैं। इसी प्रकार से अगला जो है पाई चार्ट है। ये इसमें हम क्या करते हैं? पाई चार्ट में ये में हम 100% का डिस्ट्रीब्यूशन कर, ये एक सर्कल स्टैटिस्टिकल ग्राफिक आर्क लेंथ होती है यहाँ पर। जैसे यहाँ रेड कलर अपन देखें तो इसकी आर्क लेंथ ये जो दिख रही है, आर्क रिप्रेजेंट करता है ना। तो ये आर्क लेंथ किसके प्रोपोर्शनल होता है? क्वांटिटी की, डेटा की क्वांटिटी के प्रोपोर्शनल होता है। यानी जिस कैटेगरी की आर्क लेंथ जितनी ज्यादा होगी वो उस डेटा की जो फ्रीक्वेंसी होगी वो उतनी ही ज्यादा होगी। ठीक है, तो यहाँ पर अपन क्या देख रहे हैं, सबसे ज्यादा फ्रीक्वेंसी किसकी है? ये मेनलैंड ये दिख रहा है ना, ये इधर वाला, ये दिस पोर्शन। तो यहाँ हम कह सकते हैं कि ये सबसे ज्यादा ये कुछ है कोरोना के समय के जो केसेस कंफर्म हुए थे डिफरेंट कंट्रीज में, उनकी संख्या इस पाई चार्ट के माध्यम से बताने का प्रयास किया गया है। नेक्स्ट जो है दैट इज लाइन ग्राफ। लाइन ग्राफ के हम लोग अपने कॉस्मिक रे रिसर्च में वाइडली लाइन ग्राफ को यूज करते हैं। तो इसकी जो एक्स एक्सिस होती है उसको हम लोग कैटेगरी एक्सिस बोलते हैं और ये कॉमन एक्सिस होती है, और जो बाई एक्सिस होती है दैट इज कॉल्ड डेटा वैल्यू। ठीक है, तो यहाँ बाई एक्सिस में आप 1 2 3 4 कितने भी वेरिएबल उनकी रेंज और इस बीच मतलब हुए इस डेटा को हमने रिप्रेजेंट किया है। तो यहाँ पर जो डेटा है आपका, आप एक बार होंगे अपनी स्क्रीन पर, ये सभी डेटा जो है जैसा ओरिजिनल कॉस्मिक रे का डेटा या सनस्पॉट का डेटा होता है वैसा नहीं दिख रहा है। तो एक्चुअली हमने इसमें क्या किया है कि उस डेटा को प्लॉट करने से पहले हमने उसकी स्मूथिंग की है रनिंग एवरेज के स्टैटिस्टिकल टेक्निक्स के थ्रू। मूविंग एवरेज या रनिंग एवरेज जिसको बोले, तो 30 मंथ का मूविंग एवरेज लेकर के इस डेटा को क्या किया गया है, स्मूथ किया गया है। इसलिए ये बिल्कुल स्मूथ टाइप का डेटा आपको दिख रहा है। स्मूथ लोग इसलिए करते क्योंकि मैंने स्टडी है, तो इस टॉपिक पर मैं आऊंगा आज की स्लाइड में। यहाँ पर जो शॉर्ट टर्म फ्लक्चुएशंस है उनको दूर करने के लिए हमने मूविंग एवरेज टेक्निक का यूज किया है और फिर उसको एक लाइन ग्राफ की सहायता से प्लॉट किया है। तो यहाँ आप जैसा हम सभी जानते हैं, मैक्सिमम लोग मुझे लगता है कि स्पेस फिजिक्स वाले हों, ये ओलू कॉस्मिक रे का डेटा और सनस्पॉट एरिया का डेटा और सनस्पॉट नंबर जो 2 है, सनस्पॉट एरिया और सनस्पॉट नंबर, ये दोनों एंटी कोरिलेशन में कॉस्मिक रे के हैं, जैसा कि हम सभी लोग जानते हैं। सिमिलरली अगला जो हम वाइडली यूज करते हैं दैट इज स्कैटर ग्राफ, या उसको हम एक्स वाई ग्राफ भी कहते हैं। तो ये एक्स वाई ग्राफ क्या बताता है, इसमें 2 वेरिएबल होते हैं, 2 वेरिएबल के बीच में इस ग्राफ को हम लोग प्लॉट कर सकते हैं, एक्स और वाई। तो एक्स एक्सिस में एक्स वेरिएबल और वाई एक्सिस में वाई वेरिएबल। यहाँ पर ध्यान ये है ये है तो ठीक नहीं है, क्या करना इंडिपेंडेंट वेरिएबल कौन सा है। तो जैसे स्टडी में रूप से हम तो क्या का हम यूज स्पॉट नंबर और बाइक में डेटा लिया है। तो साइकिल डेटा आपको दिख रहा है, दोनों के जो पॉइंट है वो भी अलग अलग कलर में यहाँ पर दिखाए गए हैं और दोनों के लिए हमने स्ट्रेट लाइन भी फिट की हुई है। तो ये सोलर साइकिल 20 और 24 की बेस्ट फिट लाइन भी आपको यहाँ पर दिख रही है। तो इस प्रकार का जो ग्राफ होता है वो क्या कहलाता है, स्कैटर ग्राफ कहलाता है। तो स्कैटर ग्राफ ये शो करता है कि जो y वेरिएबल है वो x पर कितना डिपेंडेंट है, या कि डिपेंडेंट नहीं है। अगर डिपेंडेंट नहीं होगा तो उसका शेप किस प्रकार का दिखेगा, अगर डिपेंडेंट है तो पॉजिटिवली डिपेंडेंट है कि निगेटिवली डिपेंडेंट है, ये भी हम मात्र स्कैटर ग्राफ को देख करके बता सकते हैं। तो यहाँ पर आप देख रहे हैं कि जो लाइन्स है ये ऊपर से नीचे की ओर आ रही है। इसका सीधा सा अर्थ ये है कि जो y वेरिएबल है वो x पर नेगेटिवली डिपेंडेंट है। नेगेटिवली डिपेंडेंट का अर्थ क्या है कि जैसे x वेरिएबल बढ़ेगा वैसे y वेरिएबल की वैल्यू घटेगी, यानी दोनों अपोजिट फेज में है। ठीक है, तो अगर पॉजिटिव फेज में होते इस प्रकार से जाती, x एक्सिस से ऊपर y एक्सिस की ओर जाती। तो हम लोग जानते हैं कि सन स्पॉट नंबर और कॉस्मिक रे बीच में कोरिलेशन है, दैट इज नेगेटिव कोरिलेशन। तो नेगेटिव हमें दिखाई पड़ रहा है। तो इस प्रकार से हम विभिन्न प्रकार के डेटा को और विभिन्न प्रकार के डेटा के बारे में रिलेशन को अपने ग्राफिकल रिप्रेजेंटेशन द्वारा यहाँ पर दिखा सकते हैं। आप नेक्स्ट टॉपिक पर आते हैं, दैट इज मेजर ऑफ सेंट्रल टेंडेंसी। तो अब ये सेंट्रल टेंडेंसी वर्ड लिखा हुआ है और मेजर वर्ड लिखा हुआ है। तो मेजर का मतलब तो सीधा सीधा सा है कि कोई चीज हम उसका मापन कर रहे हैं। सेंट्रल का मतलब भी आप जानते हैं, सेंट्रल का मतलब केंद्र, अभिकेंद्र, जो भी उसको कहें। टेंडेंसी का मतलब कि उसकी टेंडेंसी यानी उसकी प्रवृत्ति किस प्रकार की है ना। तो सेंट्रल की प्रवृत्ति डेटा की कितनी है, यानी जो हमारा डेटा सेट है वो अपने सेंट्रल पॉइंट की जाने की कितनी है, इसको मेजर करने के लिए हम मेजर ऑफ सेंट्रल प्रमुख 3 सेंट्रल टेंडेंसी को हम यूज करते हैं। उनका नाम है मीन, मीडियन और मोड। ये आप सभी चुके हैं, इसमें कहीं किसी को कोई कंफ्यूजन नहीं होगा। मैक्सिमम जगहों पर हम लोग ये भी जानते हैं कि हम मीन का यूज करते हैं, क्योंकि ये मीन क्या है कि स्टैटिस्टिकल जो एक्यूरेसी होती है वो मीडियन और मोड की तुलना में मीन की ज्यादा होती है। लेकिन कुछ पॉइंट्स ऐसे होते हैं, कुछ स्टडी ऐसी होती हैं जहां पर कि हम पर्टिकुलरली मीडियन या पर्टिकुलरली मोड का यूज करते हैं। अब ये अगर हम मीन की बात करें, जैसा मैंने कहा कि मीन आपका इसकी स्टैटिस्टिकल एक्यूरेसी मीडियन और मोड से ज्यादा होती है। तो सिंपल सा फार्मूला है इसको, ये x बार इज इक्वल टू समेशन xi अपॉन n, यानी जितने भी डेटा सेट है उन सभी को जोड़ दे और नंबर ऑफ डेटा पॉइंट्स जो है कैपिटल N उससे उसको डिवाइड कर दें, तो उस डेटा नीचे लिखा है। मीन जो है इसके 2 कारण हैं। अगर हम डेटा सेट में हर एक पॉइंट का डिविएशन मीन से लें, डिविएशन मतलब क्या हुआ कि हम हर एक डाटा पॉइंट को मीन से सब्सट्रैक्ट करें और घटाने के बाद हमारा नंबर आता है उसको ऐड करें। जैसे मान लीजिए कि 5 डेटा पॉइंट्स आपके पास हैं, 1 2 4 5, तो इसका मीन लगभग 3 आएगा। तो 1 को 3 से घटाएं, कितना आया आंसर -2। 2 को 3 से घटाएं, आंसर -1। 3 को 3 से घटाएं, आंसर 0। फिर 4 को 3 से घटाएं, आंसर 1। 5 को 3 से घटाएं, आंसर 2। तो ऊपर -1 -2, नीचे +1 +2 और बीच में 0 है। तो इन सब का जो एल्जेब्रिक सम होता है वो हमेशा 0 होता है। यानी मीन के अबाउट अगर कोई डिविएशन डेटा पॉइंट का हम देखेंगे तो हमेशा आपको 0 मिलेगा। और अभी आप देख रहे हैं कि कुछ पॉइंट्स नेगेटिव में आ रहे हैं, कुछ पॉइंट्स पॉजिटिव में आ रहे हैं डिफरेंस के बाद। इस नेगेटिव और पॉजिटिव को हटा करके अगर हम इसको स्क्वायर कर दें तो जो नेगेटिव वैल्यूज हैं वो भी पॉजिटिव में हो जाएंगी। तो स्क्वायर ऑफ द सम ऑफ द स्क्वायर जो होगा दैट इज मिनिमम। यानी अगर हम मीन से डिविएशन लें और उसका स्क्वायर करके सम करें और मीडियन से हम डिविएशन लें और उसका भी स्क्वायर करके सम करें, तो जो मीन डिविएशन से जो निकलेगा वो हमेशा मिनिमम होगा। सम ऑफ द स्क्वायर्स इस केस में हमेशा मिनिमम होंगे। तो ये सिंपल एवरेज था। इसी प्रकार से अभी जैसा मैंने आपसे कहा, एक फिगर आपको दिखाया था मूविंग एवरेज या रनिंग एवरेज। तो ये इसलिए यूज जाता है, ये भी बताया, डेटा को स्मूथ करने के लिए या शॉर्ट टर्म या लॉन्ग टर्म के फ्लक्चुएशंस जो हमारे डेटा में होते हैं जिनको हम की अपनी में नहीं लेना चाहते, उनको दूर करने के लिए हम लोग मूविंग एवरेज का यूज करते हैं। और ये कॉस्मिक रे ऑब्जर्वेशन की स्टडी है, इस प्रकार के मूविंग एवरेज का यूज किया जाता है। तो मूविंग एवरेज हम निकालते कैसे हैं? आप लोगों ने निकाला होगा, आजकल कंप्यूटर में एक्सेल में रखते हैं पॉइंट्स और वहां पर उसको जाता है, लेकिन एक्चुअल में इसकी मेथड क्या है? तो क्या करते हैं, से का मूविंग एवरेज देते हैं। तो ये 13 मंथ का लेते हैं, इसके
Due to some technical problem, our speaker is not available. We will trying to reach as soon as possible.
क्या?
हाँ सर,
अभी आवाज, हाँ, मैं
आवाज आ रही है।
सॉरी, किसी का। ओके
जी
अभी समय कितना अपने पास
है सर? अभी
संदीप
आपके
जी,
पास समय है
कितना?
10 मिनट है सर।
ओके ओके, थैंक यू। तो हम लोग मूविंग एवरेज है ये, तो इसको कैलकुलेट करने के लिए सबसे पहले हम लोग क्या एक विंडो सेलेक्ट करते हैं। जैसा मैंने कहा कि हम लोग अपने रिसर्च में सामान्य रूप से 13 मंथ का मूविंग एवरेज कैलकुलेट करते हैं। तो ये 13 मंथ का मूविंग
स्लाइड
एवरेज
आपकी विजुअल नहीं है सर।
अच्छा, अभी आ रही क्या?
नहीं सर,
नहीं आ रही। तो
प्रेजेंटेशन नहीं हो रहा।
हाँ, मैं एक ट्राई कर रहा हूँ फिर से। अभी दिख रही क्या?
हाँ सर, दिख रही। प्रेजेंटेशन सही नहीं है सर।
मूविंग एवरेज है?
हाँ ठीक है सर, ठीक ठीक है।
दिख रही? हाँ ओके।
हाँ हाँ
तो
दिख रही
एक
सर।
वीडियो करते हैं। थैंक यू। 13 मंथ का मैंने बात की, तो 13 मंथ एक्चुअली जो है ये जो कोरिलेशन होता है ये है उस को हम एवरेज के लिए चूज करते हैं। ऑटो कोरिलेशन बारे में भी मैं आगे बात कर, ये सेल्फ सीरीज को 2 पार्ट में बांट करके और उसका ऑटो कोरिलेशन किया जाता है। सामान्य रूप से जब बाइवेरिएट कोरिलेशन हम लोग कैलकुलेट करते हैं, हमारे पास तो उसको उसी सीरीज को कैलकुलेट करते हैं। तो एवरेज हम लेना है, तो इसका मतलब ये हुआ कि पहले 13 पॉइंट्स को चूज करेंगे और उस 13 का एवरेज, उस एवरेज को कहाँ लिखेंगे? तो सेंट्रल पॉइंट कौन सा होगा 13 के लिए? 6, मतलब वो 6वें प्लेस पर उस कैलकुलेट किया लिखेंगे। नेक्स्ट स्टेप में क्या करेंगे? हमारा पहला है और मतलब 14 जो है, तो 14th जुड़ जाएगा फिर उसको लिखेंगे ठीक छठवें, जहां पर लिखा है जो जाएगा को लिखेंगे 7वें में। सो इस प्रोसेस को आप करते जाएंगे तो क्या हर एक पॉइंट के लिए आपको एक एवरेज मिल रही है, और फिर इस एवरेज वैल्यू को आप प्लॉट कर सकते हैं आसानी से, जैसा कि मैंने स्लाइड दिखाया। तो ये जब हम केवल अकेले सेंट्रल टेंडेंसी की बात करते हैं तो हमको डेटा के बारे में कंप्लीट नॉलेज नहीं होता। जैसे उदाहरण देखिए, यहाँ पर 3 डेटा डिवाइडेड बाई 5 9 आएगा। इसका क्या हुआ, और एक साथ तो और नीचे हम हम से में किसी भी पॉइंट में
Due to some technical reason, our speakers left to meet. We are trying to keep reaching We are trying to reach him. Please keep patience.
हेलो,
हाँ सर, बोलिए।
अभी बीच में डिस्कनेक्ट हो गए थे ना?
जी।
ठीक, मैं एक बार फिर से ट्राई करता हूँ। स्क्रीन विजुअल है?
हाँ सर, विजुअल।
तो ठीक है, हम लोग बात कर रहे थे डेविएशन की। तो कई प्रकार के डेविएशन की बात हो गया था। तो डिस्पर्सन में हमने रेंज की बात, क्वार्टाइल डेविएशन की बात की। अब मीन डेविएशन है, तो ये the mean of the absolute value of the numerical difference between the numbers of a set and the mean, median or mode, जिसके अराउंड हमको ये डिविएशन कैलकुलेट करना है, वो डिविएशन कहलाएगा मीन डिविएशन और मीडियन डिविएशन और मोड डिविएशन। ठीक है, तो इसका फार्मूला यहाँ पर लिखा हुआ है। कैसे इसको, मतलब हर एक वैल्यू को क्या मीन या मीडियन या मोड जो भी केस हो उससे घटाना पड़ेगा। फिर तो ये इसकी प्रॉब्लम है कि यहाँ पर अगर निगेटिव वैल्यू आती है तो उसको भी हमें पॉजिटिव की एब्सोल्यूट वैल्यू करके इस प्रकार के डेविएशन की, जिसको हम आगे चल के दूसरे की बात करेंगे उसमें इसको दूर करते हैं। तो इस फॉर्मूले मीन डेविएशन कैलकुलेट किया जा सकता है। तो इसमें पिछली वाली जो बहुत सारी समस्याएं थी वो सॉल्व होती करने में भी आसान है और भी है, लेकिन और है कि बस जो नेगेटिव पॉजिटिव वैल्यू जो है इनको टेक्निक मतलब को कंसीडर करते हैं। तो जो हमारा है जिसको आप सभी लोग यूज करते हैं उसकी करते हैं, दैट इज कॉल्ड। अब स्टैंडर्ड करते हैं माइनस साइन फॉर्मूला यहाँ पर लिखा है। तो ये जाता है, सारी जो हमारे पॉइंट्स है मीन से सब्ट्रैक्ट किया जाता है और सब्ट्रैक्ट करने के बाद उसका डिफरेंस लेकर के डिफरेंस का स्क्वायर करते हैं और फिर टोटल नंबर ऑफ डेटा सेट से उसको डिवाइड कर देते हैं, तो आपको स्टैंडर्ड डिविएशन मिल जाता है। नेक्स्ट इज कोफिशिएंट ऑफ डिस्पर्सन। किस प्रकार से जितने भी रेंज, क्वार्टाइल डिविएशन, मीन डिविएशन और स्टैंडर्ड डिविएशन, इनको अगर कोफिशिएंट के रूप में प्राप्त करना हो तो रेंज को a-b/a+b, इसी प्रकार से क्वार्टाइल डिविएशन जो है उसकी भी रेंज प्राप्त कर सकते हैं और स्टैंडर्ड डिविएशन जो है उसका भी कोफिशिएंट प्राप्त कर सकते हैं। कोरिलेशन हम सभी लोग कैलकुलेट करते हैं। संदीप समय होगा भी
सर, कंक्लूड करिए,
हेलो।
समय कम है।
ठीक है, ठीक, कोई बात नहीं। तो हम सभी लोग कोरिलेशन टेक्निक्स का यूज करते हैं और दो सीरीज के बीच में कोरिलेशन किस प्रकार से स्कैटर डायग्राम के माध्यम से, जैसा मैंने बताया था, ये पॉजिटिव कोरिलेशन आपको दिख रहा है, पहला वाला जो है यानी ऊपर की ओर जा रहा है, दूसरा वाला नीचे की ओर, मतलब ये नेगेटिव कोरिलेशन है, और ये सब स्कैटर्ड है, इसका मतलब नो कोरिलेशन है। तो ये मात्र फिगर को देख करके ही हम लोग बता सकते हैं कि हमारा कोरिलेशन पॉजिटिव है, स्ट्रांग है या वीक है, नेगेटिव है, स्ट्रांग है या वीक है, या दोनों चीज के बीच में कोई कोरिलेशन ही है। तो पॉजिटिव कोरिलेशन का मतलब भी मैंने आपको बताया था कि एक सीरीज के बढ़ने के साथ दूसरी सीरीज का बढ़ना, एक कोरिलेशन का मतलब कि एक सीरीज के बढ़ने कोई अगर तीसरे फैक्टर मैंने किया है की थी, ठीक उस प्रकार से इस भी दो उसको लिखा पर जाएगा वही, जैसा कि अपना मूवी में, तो अगर उसको 26 नंबर पे आएगा, ये 50 या 51 जो भी उसको हम लोग कहें, फिर उसके बाद ऊपर वाला एक डेटा सेट आएगा, का 51 आ जाएगा, यानी ऊपर से एक एक टाइम नीचे वाले एक में प्लाट करते हैं, जैसा कि आपने देखा मेथड अभी ये चल सकता है, लेकिन समय है ने मुझे अवसर दिया ने इस राष्ट्रीय वेबिनार में जुड़ने के लिए, और थोड़ी बहुत जानकारी मैंने आप लोगों के बीच में साझा की। एक बार फिर से आयोजन समिति के सभी सदस्यों को अटल बिहारी वाजपेयी हिंदी विश्वविद्यालय की तरफ से बहुत बहुत साधुवाद, बहुत बहुत शुभकामनाएं। धन्यवाद।
Thank you so much, sir, for your valuable lecture. Now it's time for paper presentation. Our first participant is Dr. Pawanjit Kaur, Assistant Professor, School of Applied Science, Sri Venkateswar University, Amroha, Uttar Pradesh.
Sir, I'm audible.
Yeah, you
Am I
are.
audible, sir? Okay, fine. I'm going to share my screen.
Ma'am, you have only 10 minutes for your presentation.
Fine, sir. No problem. Vijay, sir, kindly stop sharing your screen so that I can share my screen. Sir, Vijay, Shah, sir. Kindly
Yes.
stop sharing your screen.
Yes, I have stopped it.
Okay, fine. Thank you,
हाँ
sir.
सर, हो गया.
Is my screen visible?
It is.
Okay, fine. So, very good afternoon to one and all present here. This is Dr. Pawanjit Kaur, Assistant Professor, School of Applied Sciences, Sri Venkateswara University, Amroha, India. And the topic of my presentation is Synthesis and Progress in Metal-Organic Frameworks Utilizing Supramolecular Carboxylate Linkage. So these are the key points that I'll gonna elaborate one by one. So What are mm, metal organic frameworks or MOFs? These are the compounds that comprises of metal ions or metal clusters that are coordinated to organic ligands or bridging ligands. They have outstanding physical and chemical properties, so they can show potential applications in various fields like environmental protection, bioinorganic chemistry, medicinal applications. So there are a variety of applications of MOFs. But why carboxylate group in MOFs? Like, what is the purpose of using carboxylate group? So carboxylates can adopt variety of bridging conformations like sin-sin, sin-anti, anti-anti, or monatomic linkages that generally formulate variety of molecular assembly. And metal organic frameworks with the carboxylate linkages have shown applications in the area of medicines, bioinorganic systems, catalyzers, and electrochemical. So what were our findings from the literature? We studied many bridge complexes with carboxylate ligands, and there are carboxylate group. The carboxylate group is the adaptable one according to various dimensions. Like we talk about 2D structures, 3D structures, whatever the structures could be, the carboxylate ligands are really adaptable. According to their adaptability to various dimensions, they are showing the application in the mentioned areas. So accordingly, we formulate the objectives and research methodology got formulated. The objective research was designing and structure elucidation of the ligand, new novel ligand, then the synthesis of carboxylate bridge transition metal complex with that ligand, and finally the characterization of carboxylate bridge transition metal complex. And accordingly, this is the methodology. Now let's talk about the synthesis of ligand. The ligand got synthesized by 6-methylpicoline aldehyde and dimethylethane 1,2-diamine by refluxing, followed by reduction, and finally reacting it with lithium hydroxide and methanol. And then reacting this ligand with zinc metal salt, I got the zinc complex. This is the zinc complex, which is a dimer. So these are the instrument specifications, the instruments that were used in the analysis of ligand and the complex. As we can see, elemental analysis using the Thermoquist EA111OCH. And spectroscopic measurements were made using, for example, IR was done by Bruker Vector 22, UV was done by Perkin Lambda 2, and Agilent A5 direct spectrophotometers. Proton NMR seen on JNN LA 400 megahertz spectrophotometer detection also collected over Bruker Smart FX CCD spectrometer. Then the DFT, D3 lead technique was used to compute all the geometrical parameters using 6311G++ DP basis sets. We have used Gaussian 9W and Gauss-View 5 software to create optimal molecular structure with least amount of energy. Further, MEP analysis was done, which is the representation of charge density of the molecule to predict the electrophilic and nucleophilic attack of the reagent. Then molecular docking was also done. So these were all the instruments that were used in the research. Finally, this is the optimized symmetrical structure of the ligand. It was optimized by DFT B3 leak approach using 6311++ GDP basis set. And this is the UV spectra of the ligand in methanol that was observed to be at 267 nanometer, as shown in the figure. This peak indicates the intra-ligand charge transfer from. Well, experimental vibration analysis, FTIR of ligand is also taken, and we compared it with calculated spectra by using the basis set B3 6311 plus GDP. So by looking at those IR spectra, we can formulate that C double bond C stretching vibrations are anticipated within the range of 1300 to 1000 centimeter inverse. And if we compare the theoretical and experimental values, it is clear that all the C double bond C and C single bond C bonds fall in the suitable region. Then the NMR experimental values of the ligand were taken using deuterated methanol on a Bruker Advanced 400 FT-NMR and compared it with the theoretical one. We conclude that there is a high correlation between theoretical and experimental values. So here, this picture on the left shows the HOMO-LUMO energy gap of 4.61 eV that was done by using B3 basis set, and it shows that enough charge is transferred within the molecule. The picture on the right, it shows the molecular electrostatic potential analysis, which gives a 3D representation of charge density of molecule. From here, we can predict electrophilic and nucleophilic attack of any region. Here, the strongest repulsion, as we can see the red color. So the strongest repulsion shown by red color, which is the electrophilic attack, and the strongest attraction shows by the blue color, which is a nucleophilic attack. This figure shows the ELF analysis. ELF analysis, that is electron localization function analysis. Blue area here, it shows the low electron localization zone between inner and valence orbital of heavy atoms, and the green projection here, the green projection, it is the surface of delocalized electrons. And here, C double bond O and C single bond C covalent bond regions have high ELF values. This is the molecular docking of the ligand, and we can predict most favorable proteins for docking using Chimera 1.14 and Autodock Vena software. From this table, it is clear that binding energies are, as we can see, it's 6.3, minus 6.3, minus 6.2, and minus 6.1, which justify bioactive nature. After docking, we obtain 2D molecule figures with the help of Discovery Studio 2 that shows different interactions in this figure. So the results of molecular docking demonstrate that ligand is an anti-microbial agent with binding energy of minus 6.3 kilocalories per mole. Now this is the discrete syn-anti-carboxylate bridge binuclear complex formed by the ligand, which is confirmed by X-ray crystallography. It is clear that the zinc ions are bridged by carboxylate oxygen in syn-anti mode, and it is also clear that the ligand acts as tetradentate ligand towards each zinc ion and acts as a bridging ligand to afford dimers utilizing the appended carboxylate group. Okay, here we can see that each zinc ion is coordinated with a methyl pyridyl N1 nitrogen, two tertiary amine nitrogens, which is N2 and N3, then carboxylate O1 from the ligand and O3 from the methanol solvent. We have also done the UV visible spectrum of the complex that shows a peak at 268 nanometer, which indicates ligand to metal charge transfer transition, followed by IR spectrum of the complex. Now, this is the NMR spectrum of the complex, which was taken in deuterated acetonitride. So, on my concluding remarks, it is evident from the molecular docking that ligand is effective antimicrobial agent. And from MEP analysis, we understand the intermolecular interaction, hydrophilic and hydrophobic nature, along with its complex building capability. Due to the biocompatibility of zinc-based molecular organic frameworks, are ideal candidates for target drug delivery. Due to their ability to capture bioactive molecules in their moiety, in their cavity, they are being utilized in tissue engineering also. So these were the references that I have used in my research. Thank you so much for your patience. Thank you.
Our next participant, Dr. Amit Kumar, Professor, Department of Electronic Science, Bhaskaracharya College of Applied Sciences, University of Delhi. Please be ready for your presentation.
Yes. Let me share my screen first. I hope my screen is visible now. Hello.
Yeah, it is visual, sir.
Thank you, sir. Thank you. So my name is Amit Kumar, and I am working as a professor in Department of Electronic Science at Bhaskaracharya College of Applied Sciences, University of Delhi, Southwest Delhi. So today I would like to give my work which I have collected for the next generation of devices that are prominent, and how the prospective end of Moore's law is coming, and what are the imminent remedies towards that. So Moore's in 1965, he predicted that the number of transistors in a microchip will double every 2 years, while the price of the device will cut off. He was the co-founder of Intel Industry, and this techno-economic model, which was proposed by Moore, that the performance and functionality achieved by the digital chip will double within the fixed cost and power and area in every 2 years, was to follow till say 2010. After some technical issues which are coming. Why? Because the most of the devices till 2010 were based on MOSFETs, and most scaling of MOSFETs are not creating the problems. Why they are creating the problems? Because we are going to the very small size chip making. For example, Intel in 2025, he is the current CEO of Intel, and he predicted that he is saying that now the Intel is moving towards 7 nanometer design. So device size, when the device size is so small that electron not on fails to satisfy the classical physics, in fact they move on to quantum physics. Their behavior changes, and that is why the scaling of the MOSFET is getting failed. Intel prospects that in 2025 they will be making chips in 7 nanometers, then they will be stretching towards 4 nanometer in 2030, and then to 3 nanometer, and then to in 2032 they will be moving to 20 angstrom. So at such a small scale, the behavior of electron is not classical, but it becomes quantum physics. The quantum physics now comes into the play because electron suffers the confinement effects, and that is why the classical physics which was there for before that is failing. So this is the physical limits that are creating the problems for the Moore law to follow. In fact, some of the architects of microprocessor reported that the semiconductor advancement is slowed down after 2010, and that has predicted the law of Moore to dead. Law of Moore to not follow in the future. In fact, one of the technocrat in 2022, CEO Jensen Huang, consider the Moore law to be dead now. But Intel is the industry because Murray was the co-founder of Intel, and he is the one who means given the instruction to the Intel that we have to follow this Murray's law. And Pat Turner was opposite view. Intel, the current CEO of Pat Singer, was of opposite view, and he is saying that no, Murray's law is not failing. Today, where we stand, chip that was produced in 1971 could fit 200 transistors into 1 square meter. For example, in 2071, 1 square meter of the chip contains 200 transistors. But today what we are seeing is the same size of the chip contains 130 million in the same space, and that operates 10,000 times more quickly to boot. The transistor sizes now reached the atomic scales, and that have raised the fabrication cost. Hence, the anticipated failure of the classical technological driver till today, that was empirical Murray's law by 2030s. Microelectronics industry, the business model is getting failed day by day, and that is the turning point of chip industry today. So we are standing at the turning point of the chip industry. What are the remedies? So till now, the planar FETs are made in which gate was supposed to surround the source and drain region, and channel was there. But after 2012, the structure changes to FinFET, where the gate surrounds the channel through the 3 sides. Here you can see that this gate structure surrounds this channel from the 3 sides, from the top and these 2 sides. Now we are moving to nanowire technology, where the gate surrounds not only the 3 sides but the 4 sides, and these are the nanowires which are generally used in the FET making. Okay, and this structure is called gate all around nano FETs structure. And we are now moving to nano sheet structures, and now the research is much more concentrated towards the nano sheet FETs, where the ribbon type channels are made, and that ribbon type channels are stacked vertically over the channel region, over the substrate, and so that the sub-threshold conduction reduces, and so that we can operate the smaller size FETs at the lower power. These are my contributions. In 2021, we summarized these things, and we summarized at how the VLSI designs need to be developed so that Murray's law can be tracked in the coming years. And the alternative, we produced a summary paper where we summarize the alternative designs for involving the nanotechnology that can play the temporary role, and so far as the future density will depend upon the biological. Means we are moving towards the biological and molecular, atomic, and spin-based electronic devices, and the term VLSI design will go down after 2 tens of years. This was the paper which was published in 2023, where we studied the CNT-based FET, and using the green function modeling, we examined how the gate dielectric material can enhance the drain current and quantum capacitance in a wrapped around CNT FET devices, and we found that the dielectric constant of these devices increases the current of these devices, and the nanometric device size limits the electron, and that causes the electron drain saturation early. Basically, what happens at the lower structures and lower means very low sizes structure, the supply of electron is limited, and because of that, the saturation currents comes early, and this is the problem which is creating in the CNT FETs. Thus, the dielectric and operational wise must be selected in an optimized manner, and the high dielectric materials could be used to increase the capacitance and peaking level. Now, this paper is I am working on. We are basically examining how the nanosheet FETs could be made, and the planar FETs are still in use, and that are 22 nanometer technology. And when we move towards 5 nanotechnology, then the nanosheet FETs will be excluded. And most of the research is today going on towards this ribbon type nanosheet FETs. Here we have calculated the nanosheet channel currents for molybdenum disulfide channel because it is the most suitable material that can be used for the channel making. And here the carrier transport is nanoscaled and dominated by the quantum confinement of the FET, nanosheet FET. And we have used the nanosheet simulator to calculate the currents. And these currents are basically evaluated from the ballistic current voltage characteristics by two-dimensional methods. And these are the some of the typical result of the drain current versus the gate voltage. Here you can see that the drain currents are almost sub-threshold conduction is independent of the drain voltage. And this is the big achievement because at such a small scale, this sub-threshold conduction is very much unstable. But in these devices, we are getting it to be almost independent of the drain voltage. The current is almost independent of the drain voltage. When we change the drain voltage from 0.1 to 0.4 volt, because at such a low devices, we have to operate them at the lower voltages. So voltage of operation will be around 0.1 to 0.4. And in this voltage regime, the sub-threshold conduction is very minimal. Even though there is a band banding at different gate voltages, but this gate voltage drain banding is not affecting our the drain current. So in conclusion, we can conclude that the two-dimensional state nanosheet FET can largely suppress the short channel effect. They can improve the sub-threshold swings, and they can reduce the barrier loading, and due to excellent electrostatic characteristics of MMS2 channel material. Okay. So this is what I want to say during this conference. So thanks the organizer and fellow participants for listening. Thank you very much.
Thank you, sir.
Thank you.
Now our next participant is Vindhya Srivastav, research scholar, APS University.
Firstly, good afternoon to all of you. Before I started, firstly I share my screen with all of you. Hello. My screen is viewed. मेरी screen दिख रही है आपको?
दिख रही.
Okay, thank you. So firstly, I am started with good afternoon to everyone, principal ma'am and all the professors. I am Vindhya Srivastav, research scholar, and today my topic is comparative study of geomagnetic storms during the rising phase of solar cycle. In this part that I just want to tell you, firstly I just tell you about there is working on geomagnetic storm, interplanetary magnetic field, solar wind, and solar cycle 25. So in this topic, I just working on solar cycle 25 rising phase, that is between 2020 to 2023. In this paper, geomagnetic storms are associated with solar interplanetary characteristics such as IMF, solar wind speed, product of IMF and solar wind speed, KP index, for the rising phase of solar cycle 25. In the era of 2020 to 2023. Using daily average data, we found a total 20 geomagnetic storms during the study, in which 17 geomagnetic storms was observed in the year 2023. We tested the highest intensity geomagnetic storm of 130 nanotesla during the year 2023. The result of the present analysis, it is observed that the product of solar wind velocity and the intermagnetic field is highly geoeffective compared to the solar wind velocity or interplanetary magnetic field alone. The correlation coefficient of geomagnetic storm indicator index DST with these parameters found to be high and negative during the study period. Correlation coefficient of solar wind speed with DST is 0.59 negative. Correlation coefficient of interplanetary magnetic field, that is minus 0.87. Correlation coefficient of product of interplanetary magnetic field and solar wind, that is minus 0.95. And the correlation coefficient of KP index, that is minus 0.87, have been observed. We found that the geomagnetic storm occur on the same day when the product of the magnetic field, solar wind, or product of interplanetary magnetic field and solar field and KP index reach their peak. The study of geomagnetic storm with various solar interplanetary features is useful for the study of space weather phenomena. Now, in that whole the paper which made by me, we done the use the method of data analysis, that is the Cree analysis we use on that, and we should discuss on that. That is result. We have compared the profiles of DST index with solar wind speed and reached to the conclusion that the strongest increment in the solar wind speed take place on the occurrence day of geomagnetic storm. Occurrence day, it means the 0 days. The correlation coefficient between DST index and the solar wind speed was found to be moderate during ascending phases of solar cycle. There is some figure that is represent how it should work. So in the figure 1B was focused on comparing DST index with IMF. That is the figure B. That is the representation of DST index with interplanetary magnetic field, and inferred that these parameters are highly anti-correlated with each other. With the help of these graph, we can see the relation between those is anti-correlation. We found that the strongest increment in interplanetary magnetic field occurs on the same day when DST achieves its minima without any time lag, also noticed by Pokhariya and all, 2018 for solar cycle 23 and 24. While a finite time lag of 3 hours was noticed by Sabha and Gonzalez in 1997, the sort of mismatch may be explained by a variation in time resolution, and the existence of time lag may also provide insight into the process underlying energy transfer. After investigating the connection of DST index with velocity of solar wind and interplanetary magnetic field independently, we have examined in figure C how DST index varies with product of interplanetary magnetic field and solar wind velocity. We came to an interesting result that DST is a highly anti-correlated with interplanetary magnetic field and the product of solar wind velocity. When contrasted with solar wind velocity or interplanetary magnetic field alone. The analysis clearly demonstrates the inverse alliance between DST and IMF product solar wind speed, which indicate that the strongest increment in interplanetary magnetic field and product of solar wind velocity happens on the occurrence day of the geomagnetic storm. The average correlation between these two parameters is observed to high during rising phase of solar cycle 25. Our result is a good agreement with these findings with Tiwari, Rathore, and Pakaria et al. Now we can get on conclusion. From the present study, we have concluded that DST is a highly anti-correlated with IMF and KP index. The correlation coefficient of DST with interplanetary magnetic field and KP index is found to be same and high, which clearly exhibit that interplanetary magnetic field and KP index is geoeffective parameter. DST is anti-correlated with the product of interplanetary magnetic field and solar wind velocity when constructed with interplanetary magnetic field or solar wind velocity alone. So, thank you so much for hearing me. Thank you.
Thank you. Thank you. Our next participant is Dr. Jitendra Solanki, Assistant Professor, Government College, Manawar, Madhya Pradesh. Please be ready for presentation. Dr. Jitendra Solanki, Assistant Professor, Government College, Manawar, Madhya Pradesh. Please be ready for your presentation. Dr. Jitendra Solanki, Assistant Professor, Government College, Manawar.
हेलो, आवाज सर, आपको आवाज आ
Yes.
रही मेरी?
हाँ, आ रही।
जी सर, मेरे पास कुछ इसके टॉपिक से रिलेटेड कुछ हैंड रिटन नोट्स है और तो मैं इसको डायरेक्ट विदाउट शेयर करके बता देता हूँ। चलेगा सर?
ओके सर, ओके।
जी। आवाज आ रही सर?
हाँ सर, आ रही है।
ओके, सो मैं यहाँ बात कर रहा था बैटरी के बारे में. सो इन दिस lecture I'm going to talk about on the rechargeable batteries. So today we know that in the market there are different types of batteries are available, and we have studied about it in our school days also. So nowadays many companies are putting batteries in the devices. Like हम बात करें यदि electric vehicles के बारे में, so electric vehicles are available in the market, और हम बाइक देखते हैं electric vehicle बेस पे, तो उसमें बैटरियाँ यूज़ की जा रही है. और बड़ी-बड़ी जो कार कंपनियाँ हैं वो भी आजकल बैटरीज़ का यूज़ करके अपनी गाड़ियाँ लॉन्च कर रही है मार्केट में. तो ये बेसिकली एक पॉल्यूशन फ्री इस टाइप से, और जो पेट्रोल का जो शॉर्टेज को देखते हुए और डिमांड को देखते हुए आजकल इलेक्ट्रिक व्हीकल्स को भी काफ़ी वो एडवांटेज मिल रहा है. तो यहाँ पे हम देखें यदि, तो हम सबसे पहले बेसिकली इट्स सोर्स ऑफ इलेक्ट्रिक, जो बैटरी के बारे में बात करें, सो इट्स बेसिकली ये सोर्स ऑफ एनर्जी हम इसको बोलते हैं. तो हमने यहाँ पे देखा बेसिकली कि जो बैटरी है बन रही है उसमें लिथियम आयन रिचार्जेबल बैटरी का ज़्यादा यूज़ हो रहा है. जैसे मोबाइल की बैटरी के बारे में बात करें तो अलग अलग मटेरियल्स को लेके बैटरी बनाई जाती है. हम बैटरी में जानते हैं कि जो मेन 3 कंपोनेंट्स होते हैं, इलेक्ट्रोड, इलेक्ट्रोलाइट, और 2 इलेक्ट्रोड्स होते हैं, और एक बीच में जो उनका मीडिएटर होता है इलेक्ट्रोलाइट होता है. तो इसमें सॉलिड स्टेट बेस होती है, लिक्विड वाली बेस बैटरियाँ होती है. यहाँ पे हमने सबसे पहले जो मैं इस पे थोड़ा काम भी कर रहा हूँ, सोडियम आयन को लेके हमने यहाँ पे बैटरी को लेके इलेक्ट्रोड बनाया है. सोडियम आयन को लेके मार्केट में जो है लिथियम आयन बेस्ड बैटरीज अवेलेबल है. सोडियम आयन पे काफ़ी काम चल रहा है इसके ऊपर, क्योंकि ये इजीली अवेलेबल है, और इसका जो रिचार्जेबल टाइम है, मतलब इसका डिस्चार्जिंग टाइम बहुत इसका स्लो है. मतलब आपको चार्ज करने के बाद इसका डिस्चार्ज बहुत स्लो होगा. ये सबसे बड़ा इसका एडवांटेज है, और थोड़ा चीप भी रहेगा ये, क्योंकि सोडियम का जो उसकी अवेलेबिलिटी है वो काफ़ी काफ़ी है हमारे यहाँ. तो हम बात करें यदि सोडियम आयन रिचार्जेबल बैटरी के बारे में, तो ये एनर्जी प्रोडक्शन एंड स्टोरेज टेक्नोलॉजीज जो हम बात करें तो वो बहुत ज़्यादा एक अट्रैक्शन, एक लोगों को अट्रैक्ट किया हुआ उसने. अ ग्रेट डील ऑफ अटेंशन ऑफ फॉर डे टू डे एप्लीकेशन, जो हमारे दैनिक जीवन में चीज़ें यूज़ हो रही है, चाहे मोबाइल हो, उसके बाद कार्स हो, टीवी हो, और या बसेस के बारे में बात करें, और इन सब चीज़ों का यूज़ हो रहा है. हम यदि सैटेलाइट के बारे में बात करें तो वहाँ पे भी सबसे पहले लिथियम आयन रिचार्जेबल बैटरी का यूज़ हुआ था. तो ये बहुत इसका काफ़ी इस पे ऊपर ध्यान दिया जा रहा है, और इस पे काफ़ी इस पे वो चीज़ें लेके बनाई जा रही है बैटरी को लेके. तो सोडियम आयन बैटरी के बारे में हम बात करें तो आर कंसिडर्ड एज द बेस्ट कैंडिडेट पावर सोर्स, बिकॉज सोडियम इज वाइडली अवेलेबल एंड एग्जिबिट सिमिलर केमिस्ट्री टू दैट ऑफ लिथियम आयन बैटरीज. तो सोडियम और लिथियम का जो केमिस्ट्री होता है मोर और लेस सेम होता है. देयरफॉर जो ये सोडियम बेस्ड जो बैटरी होती है, ये नेक्स्ट जनरेशन की हम बात करते हैं, अल्टरनेट इसको हम बोल सकते हैं. तो रिसर्च ऑन इलेक्ट्रोकेमिकल सोडियम इंटरकलेक्शन इन बैटरी सिस्टम हैज बीन रिपोर्टेड 1980 में इसको रिपोर्ट किया था, बट सोडियम आयन बैटरी आर नॉट कमर्शियलाइज्ड येट. सो फार दो स्टडीज ऑन लिथियम बैटरीज हैव बीन रिपोर्टेड 1970 से इसको रिपोर्ट किया जा रहा है लिथियम बेस को. और एंड द प्रैक्टिकल बैटरीज हैव बीन एक्सटेंसिवली यूटिलाइज्ड फॉर पोर्टेबल डिवाइस एप्लीकेशन इन द वर्ल्ड इन 1991. तो ये डिवाइसेस में लिथियम आयन बेस बैटरी अभी आ रही है, और सोडियम पे काम चल रहा है. Now, targeted application of research and development for rechargeable batteries has changed toward realization of the sustainable energy society with the change in social situation and development of the battery technology. Studies on sodium batteries have been attracted significant interest. 2010 से इसने काफी इंटरेस्ट लोगों का अपनी ओर आकर्षित किया है. तो हम बात करें यहाँ पे इसके बहुत सारे एप्लीकेशन है. तो लोग बहुत जनरली इस पे इलेक्ट्रोड्स पे ज़्यादा काम कर रहे हैं कि इसका जो कैथोड इलेक्ट्रोड है, और जनरली इसमें एनोड जो होता है वो ग्रेफाइट को यूज़ करते हैं, और बीच में जो हम जानते हैं कि जो बैटरी होती है बेसिकली इसमें 2 इलेक्ट्रोड होते हैं, और बीच में जो इलेक्ट्रोलाइट होता है. सो मैंने जब इसमें थोड़ा काम किया था एमफिल के टाइम पे, आज से काफ़ी 8-10 साल पहले, तो हमने सोडियम कोबाल्टेट बेस्ड एक इलेक्ट्रोड बनाया था. तो उससे हमने देखा था कि इसमें जो वोल्टेज गेन काफ़ी हुआ था हमको, और आगे इस पे काम जारी है. तो इसमें इलेक्ट्रोलाइट हमने पॉलीथिलीन ग्लाइकोल यूज़ किया था, तो जिससे हमको काफ़ी इलेक्ट्रॉन इसमें आयंस के ट्रांसपोर्टेशन में ज़्यादा प्रॉब्लम नहीं आई थी और बैटरी का रिस्पॉन्स अच्छा था। सेल से हमने स्टार्ट किया था इसमें, और इसमें जो हमने इलेक्ट्रोड प्रिपेयर किया था उसके बाद हमने सोल जेल मेथड से इसको, जो मेथड होती है सैंपल बनाने की, उसको हमने सोल जेल मेथड से ही प्रिपेयर किया था। सो इसमें जो कमर्शियली अवेलेबल, जो हम जानते हैं कि लिथियम कोबाल्टेड है, लिथियम बेस्ड जो बैटरी अवेलेबल है मार्केट में, और सोडियम बेस्ड पे अभी काम किया जा रहा है, कल इसमें काफ़ी काम चल रहा है इसके ऊपर। तो मैंने बताया कि इस दोनों की केमिस्ट्री लगभग सेम होती है और इसमें कॉस्ट वाइज भी काफ़ी फ़र्क पड़ेगा इसका। अभी हम देखें यहाँ पे तो मेन इसमें जो एनोड मटेरियल के बारे में यदि बात करें कि तो कार्बन हैज़ एज एन अट्रैक्टिव बैलेंस ऑफ रिलेटिवली लो कॉस्ट। हम जानते हैं कि इसका कॉस्ट बहुत कम आएगा और काफ़ी मात्रा में अवेलेबल है। मॉडरेट एनर्जी डेंसिटी है, पावर डेंसिटी एंड साइकिल लाइफ कंपेयर टू एनी अदर इंटीग्रेशन टाइप एनोड मटेरियल। सो केमिस्ट्री में भी इसका ज़्यादा कोई चेंजेस नहीं है। अब इसमें हमने जो आरआर केट में जो फैसिलिटी अवेलेबल है सिंक्रोट्रॉन का हमने प्लान किया यहाँ पे जो कैरेक्टराइजेशन के लिए। तो हम जैसे जनरली मटेरियल प्रिपेयर करते हैं तो एक्सरे का हम यूज़ करते हैं। यहाँ पे हमने सॉफ्ट एक्सरे एब्जॉर्प्शन जो इंडस 2 के नाम से है उसको भी हमने यहाँ पे यूज़ करेंगे। तो इससे हमको बेसिकली डिटेल इन्फॉर्मेशन मिलेगी अबाउट द जो हमने यहाँ पे इलेक्ट्रोड बनाया है, तो हमको और उसमें स्टडी करने में ईजी रहेगा और सैंपल जो इलेक्ट्रोड बनाने में हमको काफ़ी हेल्प मिलेगी। सो इसमें अब जो है बेसिकली इलेक्ट्रोड प्रिपेयर करना है, फिर उसको इलेक्ट्रोलाइट के साथ में चेक करना है, उसका कैरेक्टराइजेशन कराना है। सो दीज आर द थिंग्स इस पेपर में हम बताने जा रहे हैं, कैसे-कैसे इसका हर चीज़ का कैसे रोल रहेगा। और टू स्टडी इलेक्ट्रोकेमिकल प्रॉपर्टी भी इसमें हम चेक करेंगे, करंट और वोल्टेज और सब चीज़ें इसमें डिस्कस भी करेंगे पेपर में। तो इम्पोर्टेंस ऑफ जो वर्क है बेसिकली वो है कि synthesis of novel electrode materials for electrochemical capacitor application with easier production and less costly than the best electrochemical capacitor electrode materials known to date. Optimize synthesis of nanoporous carbon from different precursors, इसमें इसका प्रिपेयर होगा बेसिकली ये। Exploration of pseudo capacitor material based on the oxide or nitrides of transition materials, इसमें बेसिकली फाइनेंशियल सपोर्ट भी हम यहाँ पे ले रहे हैं। सो बेसिकली इस बैटरी को बनाने का यही है कि जो मार्केट में अवेलेबल है उससे हम लो कॉस्ट को बैटरी को बनाएं और उसका चार्जिंग टाइम काफ़ी कम समय में ज़्यादा आपको डिस्चार्ज आपका स्लो हो। तो यही इसके अंदर है, पेपर के अंदर बताया गया है। थैंक यू।
Thank you so much, sir.
थैंक यू सर।
It is custom that at the end of the program, we express our gratitudes to the guests and our participants, for which I request Dr. Deven Sharma, sir, to come to the mic for the vote of thanks.
I extend gratitude from bottom of my heart. Thanks to the organizers, attendees of the national webinar on recent trend in physical science, hosted by the Department of Physics at Government Model Science College, Riva, and sponsored by the Department of Higher Education, Madhya Pradesh. The webinar was an enriching experience featuring insightful discussions and presentation on cutting-edge topics in the field of physical science. I sincerely appreciate the efforts of our speaker, Professor S.K. Tripathi and Dr. Vijay Mishra. Our principal, Professor Aarti Saxena, convener and head, Dr. S. Kumar Singh, our faculty member, Dr. Ashish Gupta, Dr. Umakant Sharma, Dr. Lakshmi Tripathi, Dr. Archana Shukla, Dr. Nikhil Ranjan Jha, Dr. Sandeep Tiwari. Participants who are connected with us via online link, our student and our technical team, Dr. Ashish Sen, Dr. Ramesh Singh, different committee members, Dr. Habib Khan, Dr. Rajesh Bharti, Dr. Amitabh Misra, Dr. Ashok Misra, Dr. Sandeep Shukla, Dr. Umesh Misra, Dr. Pushpen Tiwari, and our staff who contributed to the success of the webinar. I look forward to applying the knowledge gained from this webinar in my professional endeavors. Once again, thank you for this valuable opportunity.